microphone?
I should probably have a microphone, yes. Okay. Hello, FOSSASIA. I'm very glad to be here. And I am excited to talk about my research on Chinese censorship bias in LLMs for the first time in Asia. This is collaborations with my co-authors from Citizen Lab, Mohammed Ahmed and Jeffrey Knuckle, and I am not the member of the research team that speaks Chinese, so so just if you have any specific questions about like some of the actual prompts, I can only speak to the translations there. This is not research so much about open source, but it is research about openness and related to, if some of you were in the opening sessions today talking about the importance of being able to understand what's going on with some of these black box models that we use. Okay. So, some of you might have queried LLMs, and you could imagine querying sort of ChatGPT or DeepSeek and with a simple query like, tell me about the Uyghur people. And you could get very different answers based on this, based on whether you're querying, which model you query. But I'm actually lying to you, because this is not querying ChatGPT and DeepSeek. This is just querying ChatGPT 4.0. So the only difference between these two prompts is that one of them is being prompted in simplified Chinese, and one of them is being prompted in traditional Chinese. And the difference between these two prompts are that, you know, one of these is spoken much more in Taiwan and Hong Kong and various parts of the Chinese diaspora, and one is spoken much more in mainland China. And the question is, why is it that, you know, you query the same model with just a different character set and you get a different response? Maybe this is a good thing. Maybe in some cases you would want to tailor your response to the cultural situation of the people that you are, you know, that are querying you. But at the same time, as a user of these systems, it would be good to know if, you know, if I were to be querying this in a different character set, am I going to get a very, very different answer? So we're not, in this case, talking about explicit censorship. So when you query a model about, like, you know, a sensitive topic and you get a refusal to answer, which is actually probably what does happen a lot of time with DeepSeek. So if you ask DeepSeek about things like Tiananmen Square, it will say, I don't want to talk about that, can we talk about something else, right? But this is about implicit effects on the outputs of LLMs. So I'm going to then move on to talk a little bit about the background about why this might happen at all. So, AI systems are prone to biases that are found in their training data. So you train your model on various internet things, and your model is going to reflect the text that's there. LLMs tend to be trained on large amounts of data from the internet. The most common approach to training like these big frontier models is to use what's called the common crawl of the internet, plus whatever other data that the model builders can get their hands on. Now, if you look at text from the internet, this is going to include lots of text that is subject to various government censorship practices and programs, and thus made up of sanitized content. And this is not just a Chinese censorship issue. There's censorship that happens all over the world in different ways, and all of the models have various types of choices made about what's going to be included and not included, and things like that. Part of the reason that we were able to study Chinese so well is because we have this really interesting Unicode point ability to just change to not worry about translations or anything else, and just change the character set and see these results. Plus English and Chinese are both very highly resourced languages, so we're not going to be as much suffering from the problem of low resource languages, which can also cause results to be different. which is another interesting thing if you are querying models in other languages, like say Thai, which is not a low resource language, but it's medium resource, so you may get different answers than querying in a highly resourced language anyway. So there are all sorts of interesting effects, and I encourage you to play around a little bit querying models in different languages and seeing how the results differ. It is the case that the most recent models are a little bit less subject to the exact effects that we found in this paper. And we're still doing some research to understand like how deep those like changes and fixes go. So, sanitized content, as I said, is what we'll define as the content that's left behind after being subject to deletions or alterations via state censorship, either directly, the government takes something down or orders something taken down, or through self-compliance, people know that you're not supposed to talk about this thing or in this way when you discuss it on the internet. So, and then we'll talk about censorship bias, which is just the bias in the overall model that results from training a model on this content. Okay, so now I'm going to talk about the design of the research, sort of how do we go from let's just play around with some prompts and see if the results are different to something that is a little more rigorous. And I will say here that I won't be able to go into a huge amount of detail, but we do have a paper from the Privacy Enhancing Technology Symposium. So if you Google for that and my name and the analysis of Chinese censorship and LLMs, you will find the PDF, and it also links to, under the artifact, it links to our Hugging Face repository. So if you want to play around with the actual like code and models and some of the classifiers we have, I think not absolutely everything is up there, but quite a bit, and you can query us if there's something missing that you wanted to play with. Yeah. Okay, so yes, simplified Chinese versus traditional Chinese was the way that we were able to do these kinds of measurements. So basically we built prompts that were just tell me about noun. So we could say tell me about Xi Jinping, and we could then translate that into simplified and traditional Chinese and do these queries and compare the responses. So a little bit about how we chose the prompts. We chose just tell me about as a very simple way to do it, but okay, first I'll just say how we picked the words. So my colleagues at Citizen Lab have done a lot of research to try and understand like what types of words are censored on, is this like blinking behind me? I don't know. Sorry about that. In the Chinese internet, and they built a list of censored keywords, names of dissidents, manually generated subjects that they thought were censored. Now again, as I mentioned, it's also the possibility that you're going to get different results, not because of any kind of censorship, but just because of cultural variation, or just because of general stochasticity or randomness. So we also picked a set of 500 random nouns, and we took out any nouns that we thought might be at all politically sensitive, which is how we got it to 491. And we used, when we were comparing our responses, we wanted to see that the results were statistically more different in the like more sensitive censored set than in the random noun set, to sort of distinguish just like random differences or just like basic cultural differences and things like that in our responses. It's not, we still can't do a causal analysis, but we do have some information there. So we also worked very hard, apologies to anyone who has epilepsy, to try and use open-ended responses versus constrained responses. Those of you that have played around a little bit with jailbreaking models know that like you can get very different responses when you asked for like constrained responses where you just give it a multiple choice question, or you give it like a answer in true false or something like this. So we used these open-ended prompts, and we weren't asking things like, is Xi Jinping a dictator, which again, we get no or a more nuanced response up here, but we could also, but so we just said, tell me about this person, so that we were hoping the prompts themselves are reasonably neutral and not like skewed in some way. Okay, models. So we used models from OpenAI and Claude and Anthropic, Claude, Google, Gemini, and Meta's Lambda. In these models, we did not use any of the Chinese models at this time. We've since done some analysis of that, but we wanted to mostly measure just these implicit censorship results that happen, not things that might be explicit, so that kind of muddies the waters there. And this is all of these queries were done basically about a year ago, or a little bit more. So we don't have, so those are the models that we analyzed, the ones that were available at that time. Okay, so then the question is, how do we actually measure differences? Well, one simple way, and there's been a lot of research on this, is just to measure like when they refuse. So if the model says, I can't answer that, or let's talk about something else, or any kind of refusal, we queried that. But we also wanted to measure these differences. So we used sentiment analysis and word embedding analysis to understand like differences in like sort of the tone of the response. As you noted when we talked about the Uyghurs, the traditional response was much more sort of opinionated, using much more loaded language than the simplified response. So we were interested to see that effect. And then we built an actual like bespoke classifier which we called censorship detector, where we trained it on Chinese language Wikipedia, which is censored in China and is largely diaspora driven, and Baidu Barka, which is an encyclopedia in China run by Baidu. And so what we did was we built a classifier to say, is the language in this response closer to one of these than the other? And we tested it using news articles from Chinese outlets versus outside outlets to see if it could classify those. And it did about 90% accuracy in classifying like which type of language this was closer to. So we were able to see if the responses were more similar to censorship detector or Baidu Barka. Okay, getting close to the end here. Findings. So we queried them both, asking for responses in Chinese and then asking for responses in English, but in both cases we're prompting them both in traditional and in simplified Chinese. And basically the check marks are for cases where we saw statistically different results in the statistically significant results over the censored keywords over the non-censored keywords, and the X's are cases where we didn't. So for every model, like there's at least some kind of evidence of differential treatment in these cases, but where it fits is quite different, and they're not all the same. And so it's an interesting thing. I'm going to move on because we don't have much time. Just talk a little bit about what's next. Obviously, like I said, these models are changing all of the time. We're working to turn our pipeline from a one-shot thing into something that is longitudinal, that can be run periodically on new models as like new topics come out, to understand kind of how these models' responses are affected and how they're different, and if you wanted to analyze things to understand if your prompt would be different in these different languages. We also want to look at different languages, non-language models, and also look at these explicitly censored models that obviously all the models are explicitly censored because they all have alignment mechanisms, but some of them are the results of like the companies doing this versus sort of state policies, and it varies. Okay. And then I wanted to do I tried to upload this. There was a QR code, but please contact me if you're interested in participating in this study. We are doing research on understanding the security and privacy effects of LLMs in the software supply chain, and understanding, what are the rules and guidelines that projects have, how they're documented, what are their security and privacy concerns over using LLMs. So that's another project we have. My student who was doing this research was supposed to be here with me, but she would have had to fly through a war zone and didn't want to do that. So that's the results of that. Thank you very much. You can connect to me here. And maybe I have time for one question. No, no questions. Okay, but I will be around.
Thank you, Rachel. I will ask, is there a best place for people to look to find you?
Like here?
Here, yeah.
I will be in a panel at 2:30, and I'm just going to be hanging out around.
Around, okay.
Yeah. And I'll be here tomorrow too.
It's a very clever technique. Yeah, okay, we can actually measure things about these large impenetrable systems, which is nice.
Trying to make them more open.
Apologies for all the blinking earlier. I think we've now turned the effects lights off successfully, so that should have stopped. Next up, we have, is this you? Okay, fabulous. So, here we go. Wenji Lu, yes, from TikTok, will talk to us about very clever ways to do ad delivery that still preserve your privacy. Assuming his slides appear on the screen.
So I have to use, can I use my laptop?
Yeah, sure.
We will. Ready? Okay, just hold it.
Perhaps once you start. Okay, 14 minutes, go.
Okay, okay. Hi everyone, it's Wen Jie from TikTok. I'm from Privacy Immunization Lab. And today I will talk about the privacy preserving ad system. And okay, just PPT wrong. Maybe just the agenda. Okay, we will first go through the ad journey, and from impression to conversion, and I will identify two privacy risk to understanding the threat, and we will show two paths in enhancing technology, PSI and differential privacy to address our issue, and finally we will introduce our open source solution, PrivacyGo. And when you are on media, social media, you see an app, and what happens here is basically your user identifier, like your email and your phone number, will be recorded, and the app's ID you sort it will record. And days pass, and if you go to an e-commerce platform and do some buying, and also your email and your purchase amount will be recorded. And the core question is, how many people saw the ads actually buy my products? It is the question from the advertiser. And actually, it's for now in the industry they relied on a Pixel SDK. It is one by one pixels embedded on the web page, and it will automatically track your touch point. Like when you open the apps, they will automatically embed your information. Like, do you click on the add to chart, or do you finish the purchase? And all the event will be sent to the app platform for the conversion report. So there's a lot of data record and a lot of data exchanges between the ad platform and the e-commerce platform. So two core privacy issue, like one is the input privacy issue, because your phone number, your email address will be sent, exchanged between the ad platform and the e-commerce platform. But maybe someone's saying, like we are using hashing. Actually, they are using hashing, but it is not enough for protecting the user privacy, because basically you're using hashing, you're not adding random sorted. They just use a simple hash. And another is the output privacy risk, because finally, basically you have to get your report, like how many people saw the ad and how many purchases they are done. So this kind of output privacy is basically not considered by the industry. because the attacker can still identify individual using auxiliary information. Actually, it's a real case. Like many years ago, BetterHelp is an app. They take inquiry from the user for their mental health information, and they share this kind of information to the social media company for the advertising targeting. They use hashing. They are not sending the plain text email or plain text form. They use hashing, but it is not inefficient like the FTC said code. The hashing is not meant to be concealed for the visitor and user's identifier. It is just barely to hide the email address from a bad actor. So we are turned to the privacy enhancing technology to protect both input privacy and output privacy. For the input privacy side, we turn to use a tool called the private set intersection. You can see, you can view it as a black box, and what it inputs is the user list, the email list or the phone list, and they will give you the comment in the use. They will give you the list in the comment. Like you have two lists, and they will output a list that the user in the comment, and nothing else is revealed during the computation. It is done within cryptographically. And for the differential privacy, it might be more popular because Apple and Google also use it to collect data user and to report statistic report. And they provided a privacy preserving range for the output, and they will prevent individual with the identification. Okay. And our methodology is to combine those, and we will show you details. And for the PSI, again, you can view it as a black box, like two platforms independently input their user list, and the algorithm will compute a list that only the common parts. And the user not in the intersection will not be revealed. And technically, what we use is called a commutative encryption. Basically, the encryption order doesn't matter. If you platform A encrypt their set using their own key, and platform B also encrypt their set using their own key. After they exchange the ciphertext, they can do the encryption again, and they will get the same result if their user list is the same. So they can do the comparison and obtain the common user in the common set. The security guarantee is that neither they can learn anything about the user not in the match set. That's called PSI. And differential privacy is much more popular, as I said, because it's used by many large companies. Basically, we add noise, carefully designed noise for the output. Like when the result is like 5 people have brought my has made the buying, and but the final result but the final report will becomes some kind of noisy answer. Like just tell you 4 to the 6th. And the formal guarantee is that not single data point can be identified when you are using the differential privacy. Also, there's parameters here, but it doesn't matter. It's just thinking like a smaller one will lead to a stronger privacy, and a larger one will weaker privacy. And actually, we done all of the development and open source our implementation. We call it Privacy Go. It is open source in GitHub. And this year, we finished the deployment on the AWS and GCP. And you can search on that market and just try to use it. we want to, because lots of this deployment needs many cryptographic background, so we just finish all the related implementation, and you can just click some button on the measures. And we hope it can be much more easier to access for the advertising ecosystem. Okay, the takeaway is that the advertising ecosystem is changing from like checking everything to become a more private first model. And we hope both input privacy and output privacy is protected. So we need multiple technology to be combined. And we want to see a more better future for the ad related, because most data have to be protected and to achieve the minimal usage standard. Okay, thank you. Sorry for the slide issue. I'm not sure.
No. Firstly, that was our mistake. It seems that we did not have an Office suite on the laptop for some reason. That has been fixed while you were speaking, so our apologies. Secondly, I said 14 minutes. We had you for a 25-minute slot, so thank you for finishing so quickly. In fact, we now have lots of time for Q&A. So, do we have questions about privacy-preserving ad tech? No? In that case, I have a question. A general strength in open source is that you're sort of finding stuff that's valuable to other people in the broader community. Have others picked up your work and started using it elsewhere?
Yeah, actually we cooperated with some advertising agency to try to connect the outside company to use this platform, because not all the company can use the Pixel SDK, because they will send many user data. Mm-hmm. For those companies, we cannot do the conversion report with them, because they are not sending the user information. So for those kind of privacy sensitive company, we introduced Privacy Go with them, and we launched some kind of communication with them. The result is quite good.
Okay, that is excellent. I've been aware of sort of homomorphic and differential privacy techniques for a long time.
Yeah.
To see them used for real is really good.
Because it had to be case by case, so the deployment cost is quite high, actually.
That's all technology, unfortunately. We still have really almost 10 minutes. No questions from anyone? So here we go.
Hey, hi.
Just curious, what was the reason why you had to build this? Was there a security privacy incident? Why did you create this?
Yeah, the question is why we created Privacy Go. Yeah, the main first, because I'm the crypto guy, so I want my tech can be used somewhere else. And secondly, like just I said, some companies do not want to cooperate with us because of the privacy issue. So we have to create some tools to bring up the confidence. Like we are not stealing, we are not checking all the data. All the data is encrypted by yourself, and to unblock more commercial benefit.
In which jurisdictions which countries? The first.
I'm not sure. I can.
Okay, that's fine. That's right. No problem. All right.
Yeah.
I was wondering.
Yeah. Basically, there are many more. Typically, the big giant technology company, they are not just sending the user data outside.
Yes, it's large companies who tend to be a little more mature, just because they've got legs in many jurisdictions and regulators prodding them.
Yes.
My real question was EU.
EU and US and
Both?
Australia.
Okay.
Yeah.
Oh wow.
Yeah.
That's amazing.
Yeah, but it is case by case. It has a lot. From prototype to deployment, it takes so long. Actually.
I've spent enough time in tech to know what what that means. So it takes a while, but it's really good to get that.
I say the meeting with those guys have to take many times.
This is
Because
like a sort of-
to convince them that this technology is safe, like because they are out of the background, out of the the cryptographic background.
Oh, yeah, like there's a lot of money flowing. So yeah, there's
Yeah, sure.
great care. All right,
Thank you.
thanks so much. So we actually, unfortunately, now have 7 minutes to twiddle our thumbs, but appreciate a quick finish. So we will be a bit quiet. You guys, actually, what you might want to do is verify that your video works. So Dinesh and Ashish will start in about 6 minutes' time. They're just going to verify that they can play their video. Can I have a sense of who's here? Are there people who are working in cybersecurity or working in privacy? None? One? Yeah, sure. Undergrads, students? No? A student? Okay, we have one student and we have one person working in cybersecurity. Who is everybody else? Okay, so developers and DevOps type. Any other DevOps type people? Marketing, right, yes. Okay, this is direct relevance. Yourself? Platform engineering, all right. Yeah. Right across the board. Yeah. I think the comment was, security comes first. Yes. I won't embarrass him by saying who, but one of the speakers yesterday during the community day was talking about security as an option. And I'm like, what are you talking about? Up comes the UN open source principles, one of which is security by design. Every IETF RFC for the internet standards has a security considerations. So yeah, we're increasingly the world is understanding security is not optional and it's not later. It's got to be part of the part of whatever you design, for sure. Others? What do you do? Are you working in a network admin? Okay. So keeping bad guys out is sometimes your responsibility? Yeah. File, like network level security is a sort of underlying thing we all rely on. All right. Who else?
Oh, okay. Yeah. Or we can plug it in, whichever way you want, whatever works. We can
Yeah. So we often lump privacy and security together. They're actually
Let me send you.
distinct
Okay,
practices.
can
Yeah,
you
get
send
that.
Bird the link?
Yourself? You said you're working in cybersecurity?
Already.
Oh, cool. Right. Right, so fintech and health tech are the two
Send the video to
like screamingly important private sector areas. Defense, obviously, but in private sector, these two in particular must be secure from the bottom up.
Done? Okay.
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 Yes. Yeah. And the more risk. Yes, that joke would be distasteful. How are we doing? Yourself? Sorry, responsible for security in? I'm still missing the word. In YDB, but... Oh, distributed database. Oh, yes, I understand. Yeah.
That's all.
Ah, okay.
Oh, it's here.
So keeping distributed systems in particular consistently secure is its own special kind of hell in my experience. Herculean, I think is the right way to say it. Yes. Ah, good stuff. You're a student? What do you study? What do you study?
Thailand.
And are you first year, second year? What's the... Ah, okay. And do you know what you want to do when you graduate? Software engineering is a large field. So, and we will just gently remind you that everything you build should be at least somewhat secure.
Yeah, 2 minutes, right?
Right, next up we have Dinesh and Ashish who are looking to defeat API blind spots with AI agents. One hopes they're helping us to detect them so we can prevent breaches, not cause them. Okay, I thought that already. I should have started you early. I'm sorry.
You said, yeah, 2:10, right?
The timetable's not
It's correct. What? No, no, ours is at 2:10. This is my time.
Yeah, but you're not going to do 25 minutes talking 20 minutes.
Yeah, it's 5 minutes of Q&A. Hopefully we'll wrap it up in 20 and then any questions after. We'll see.
Have to get a bit creative.
All right. I will try.
Right. Go ahead.
But how do you present slideshow?
I think how to present it.
Right, good afternoon to everybody in the room and the folks that have joined us on live streaming. I'm a returning speaker here in FOSSASIA. I was here last year as well. I'm very excited to be back again. Go back. Go back. Yeah. So now, what happened to this one? Yeah, but it's not moving. That's fine. Do you want to fix this? I'll keep going. A quick introduction. My name is Dinesh. I'm a security engineering manager at Google. Prior to Google, I was at Microsoft and Box on similar roles. I have about 15 years of experience building and scaling cybersecurity programs. I have a master's degree from NYU. I hold a couple of offensive security certifications as well. Quickly, I want to pass on the mic to Ashish so he can introduce himself.
Hi all, my name is Ashish. I'm a security engineer at Google. I have over 9 years of experience in cybersecurity, worked in various domains like identity and access management, input security, network security, currently focused on third-party SaaS. My passion lies in building security solutions that are solving like modern complex security challenges. I have a master's degree in CAD/CAM and robotics. This is a field I like to tinker with sometime. Good. Over to you.
All right. What's on the menu today? We'll take a quick look at what is SSPM. It is SaaS Security Posture Management. I'll tell you a little bit about their current limitations. We'll jump into how AI agents can come for your rescue. We'll take a deep dive into our solution, a demo, if time permits. And we'll share some key takeaways and jump into Q&A if we have time. All right, before we begin, I want to share that the views and opinions that we share here are our own and shouldn't be attributed to any of our previous employers, also Google. And another thing, some of the ideas that I share in this presentation is not a magic drug that will fix everything. At least they'll help you take some steps in the right direction. So SaaS is now the industry standard for software delivery. For enterprises that rely on critical business operations, they're just a black box. We know less about how they are built and managed, making them a prime target for cybersecurity attacks. To protect enterprises, enterprises use SaaS. Security teams often use something called as vendor security assessments. These are just questionnaires, point-in-time reviews that quickly become obsolete, making the entire process less effective. Last year I was here, I spoke about some essential components for building and scaling a modern SaaS security program. This year we picked one of them to dive deeper and share our learnings with all of you. Show of hands really quickly, how many of you use GitHub, Lucidchart, Salesforce at your workplace for business reasons? So assume that one of your admins actually turned off branch protection at the master branch, or your Salesforce admin approved an unsanctioned app which allows data bulk upload and download, or Lucidchart, which is used for flow charting and sensitive design documents. Somebody enabled external sharing so your employees can share it with Yahoo and Gmail addresses and you wouldn't notice. So if something like this happens, how will you detect this change and respond accordingly? The paper-based assessments, VSAs, are point in time, they won't help you here. And this is where SSPM, which is SaaS Security Posture Management, will come in. So I shared this slide last year as well. It highlights some of the top risk areas within SaaS security space. I refreshed the numbers a few days ago, and to my surprise, the application misconfiguration, all the examples I just shared with you, or do still exist. They continue to be one of the top risks with very low adoption across many of the SaaS consumers we have seen today. So how does a typical SSPM solution work? There are only two ways they work. One is either the provider of the SaaS solution gives you a set of administrative APIs that you can poll regularly to see if somebody, so for example in GitHub, you can keep querying a set of API endpoints to see if somebody disabled branch protection. Or every hour, every minute, depending on the API limitations they set, you can keep querying GitHub or Salesforce or Lucidchart to see what is being changed almost in real time. Or they go the traditional route, they log some security events, which you can consume after a day, 2 days, whatever, pull those logs into your detection response pipelines, have your DNR team run some analysis to find if somebody changed something. These are the only two ways that SSPM solutions work today. What if I tell you that these SaaS platforms, what if these SaaS platforms support neither of them? Say they don't give you standard set of API endpoints to query on a regular basis, neither log security events in their logs. And in our experience collectively, I'd say about 80% of commercially available SaaS vendors today have extremely limited API or audit logging capabilities. So what are our options? There are a few not so viable options, right? So one, you can push the vendors to go implement these features. Unfortunately, these features are not simple to just build it overnight. So it will take them multiple quarters. Those timelines might not align with your urgency. Two, you can stop using the vendor because they don't meet your security bar. It's much easier to say than it is to do it, because you can probably do it going forward for all new vendors, but disengaging with existing vendors will be extremely costly. The other is you choose to do it manually. You can ask the administrators to log into the tool every day at 9 a.m., take a screenshot of the admin portal and share it with you. I'll tell you, this is the quickest, easiest way to lose credibility with your engineering teams or your SRE teams. Last thing is you can just write it off, which is, hey, I'm going to accept the risk, but unfortunately the risk is not gone. So what do we do if none of these options come in handy? So it's a crime to not mention the word AI after speaking for 10 minutes. So I'm going to say it. So here it is. Both of us want to share a novel approach that uses AI-assisted UI agents to overcome some of these limitations, where the SaaS vendors neither support administrative API endpoints or log security events. To share more and to take you to the end, I want to invite Ashish onto the stage. So he'll share some of the implementation details with you. And then I'll come back in to share some learnings at the end. Ashish, over to you.
Thanks, Dinesh. He just laid out the reality of situations perfectly. We are dealing with blind spots everywhere in SaaS. The configuration API that we need to monitor these SaaS endpoints, like they are not existent, right? So what do we do? Like, do we wait for vendor to catch up, or like we have some solutions? So this is a solution that we want to approach. Basically, what we are building is AI-powered UI agent. They are basically your agents dedicated for monitoring your SaaS platforms. How these agent works, right? Essentially, these agents query the SaaS platform as a human auditor would do. Load the SaaS app in the browser, navigate through the SaaS app, and check its security config, and check if like those are what security config is configured in these SaaS apps. These AI agents basically have 4 critical components. First is the sandbox browser. This provides an isolated environment for browser execution. Second is the content inspection proxy. Think of this as both our auditor and kill switch. All the browser traffic is routed via this content inspection proxy. This enforces a deep ACLs, basically allowing only the required HTTP endpoints of the SaaS endpoint that you are actually monitoring. Third is a browser agent. We will talk more about this agent in this talk. But this basically takes our prompt that you want monitor for SaaS app and execute the actions on the browser to monitor the SaaS app. And finally, we have a monitoring platform. This could be your traditional logging platform, or your specialized SaaS platform, where the agent will essentially send the structured data. Let's double click into the agent itself and see like how it's navigate through the web page. It relies on a 3-step cycle we called reasoning loop. In the first step is like observation. Basically, the agent captures the current state of the page, like either via DOM snapshots, what's loaded on the browser, or the page screenshot, like a screenshot of the page. Second step is reasoning. It takes that state, combine it with our prompt, and send it to LLM. And finally, when LLM analyze it, do the reasoning, and it sends the action back to the agent. Agent understand, okay, what action need to do, execute those actions, and this cycle repeats. Let's talk about like how we're going to implement this agent actually, like what it looks like to implement this agent actually in your environment. There are multiple open source implementation actually are there. You don't need to start from scratch. Like Google Gemini, computer use, browser use, all these implementation exist. But if you have to implement these in your own environment, there are four critical steps that you could implement it from. First is like establishing a structured LLM communication protocol. This involves defining the structured way of communicating with LLM, so web agent can understand what actions LLM want us to take on the web page, execute them. This involves defining how browser state will be sent to LLM, how tools will be advertised to LLM, how execution response will be sent. The second key step involves like developing and registering executable tool set for the LLM. This involves like all the action as a human we would do on the web page, defining like how agent can do those action on the web page, like defining like click action, a scroll, function, all those things. And third key step would be implementing a continuous reasoning loop. Like once all the actions are taken, we need to basically orchestrate this complete cycle. Like agent took the actions, send the response to LLM, and how LLM will see that our task is reached or not, and again suggest another action. So how we have a continuous interactive loop is built. And the last step is orchestrating this complete process. This involves like all these key steps needs to be done. If we talk about this, how we could implement this in like enterprise setup, right? Like using LLM for just a simple task like just loading the web page on the browser is like too risky. You're just burning money, and like loading it on just using LLM for loading it on the browser, it's like you're just burning money, or like it's take lots of time as well. So in the enterprise setup, we should go for hybrid approach. Like for deterministic actions like loading the web page, clicking on some known endpoints, we should use like Selenium or already trusted historical tools. And for probabilistic nature, like navigating through a UI interactions and adapting through like some data extraction, adapting for some data extraction, we should use a LLM or web agentic framework. What will be the result of this hybrid model, right? Massive cost reduction and significant reliability of the framework. In this key setup, right, the main problem is authentication. This is a critical pillar of this framework. The golden rule is never simply share your credentials to agent. It's just too risky for AI agent. We also want to avoid like local application accounts because they don't provide like audit events. The lack of visibility is very big problem because it lets bad actor operate under the radar. To solve this, our preferred method is a programmatical credential exchange. Most SaaS app at least support the SSO. So instead of having the agent type the password and we programmatically get the SAML assertion and inject the authenticated session in the browser. So we don't need to get like local username and password. So AI don't need to handle those local username and password. Once we have that authentication session injected, the agent or application that is loaded on browser seamlessly use that and use that authenticated session for all the data extraction further. First, like as we empower this AI agent to navigate our system, we inherently create a new attack surfaces as well. We must secure this agent itself, and here are some of the key guardrails that we think that we should implement. First is like, as we discussed in the past slide, like inject, don't type. Second is the least privilege. All the accounts that you use should only be used for only have a privilege related to what it needs to use for. Like suppose if you are only used for read-only action, so it should only have like read-only action. Second is prompt hardening. In this architecture, prompt are not just chat, but we treat prompt as code. We must rigorously test this prompt under our assumption. Like suppose we're assuming a certain element exists. What happens like if those element doesn't exist, and test the unexpected agent behavior as well. Network isolation, like content inspection proxy. The agent does not get free reign on the internet. We route all its traffic to content inspection proxy and allow only specific ACLs. Last is like human in loop. If you are doing any write action on the website, make sure like humans are loop and approving those actions. Now it's a demo time of this session, in this demo like we have locally Selenium grid Docker container is running, and we will basically monitor a Figma instance and its admin configuration. So we will start the Figma monitoring job, in which like now we did the authentication exchange and we just loaded the authenticated session in the browser. So now like when we load the Figma website, it's already loaded with the authenticated session. We don't need to do any login on the browser. Now the agent understands the prompt that we have given. It's like extracting the configuration. So agent knows that it needs to click on admin settings. Then it will click on settings page. And then it will try to load all the settings that we want to monitor in a structured format that we could further send to a SSPM platform or a monitoring platform. Yeah, as I told, like agent takes some takes some time, so it's taking some time. It's sending that response to LLM, and then like we have structured data extracted. And now we'll simulate a different scenario where like agent is hallucinated by the some wrong data on the website, and now like it will try to do the actions that it is not intended to do. Like it will try to change in this simulation we have simulated like it's trying to change the default session timeout setting. We have simulated it, but it could happen due to some prompt injections scenarios. So now it will try to change this. As this traffic is routed by content inspection proxy, we see that okay, now there are the action couldn't go through because there are some that network request is dropped by the content inspection proxy. Let's go to current challenges. As promising is this agent framework is, we need to be transparent about the hurdles. There are some hurdles related to this challenge, like the web first gap. Like the web is designed for human, not for agent. So there are certain actions like scrolling and lazy loading content is like is really hard to do with this approach. Second thing is security and integrity. Even with the guardrail we just discussed, agents are still vulnerable and still can suffer from indirect prompt injection or hallucination. That's where the content inspection proxy control become very critical. And second, we have access barriers. Ironically, the security mechanism we designed to protect this platform are some of the biggest roadblock. Sophisticated anti-automation shield like bot detection tool, Cloudflare, Akamai frequently hinders this automation flow. And hardware-backed MFA are also like key challenge to handle here. I'll hand over to Dinesh for Q&A.
Thanks, Ashish. Before we share the key takeaways, I think the demo that Ashish shared is an example where Figma is a popular third-party product. It's a SaaS platform that many of the iOS developers, I think, use to create some fancy UIs for their products. And Figma, for example, say doesn't support any APIs that we can query, or they do not log those events. This is the solution to run these kind of apps within a browser context, have agents parse through the configurations, find them for us in a nice consumable format. And the content inspection proxy is key because if your AI agent, which is not supposed to write, only to read configurations, but it decides to write and change some of the critical configurations, you need some sort of guardrails, and that's what the content inspection proxy does, is to stop any post requests from going out, for example. So those kind of policies can be applied at the content proxy level. So with that, I want to share some key takeaways, and then we'll do some Q&A if we have enough time. First, SSPM is a no-brainer. I think application misconfigurations create significant attack surface, and SSPM is now an absolute necessity for any enterprise that use SaaS products at scale for various business needs. Second is agentic future is already here. AI agents are no longer used for general purpose chatting anymore. They can actually help us solve complex security problems at scale. And finally, protection is paramount. With AI and agents, we get more power. With more power comes more responsibility. And the effects of misconfigured agentic workflow may be catastrophic if we don't implement the proper guardrails like how we described. So again, thanks for the opportunity and thanks for listening to us. If you have any questions, we'll be around. If we have time, we can take Q&A, or we'll be around in the area so we can take your questions. Appreciate it. Thank you.
Thank you, guys. In fact, we are more or less on schedule. I'd like to stay there. Is Shalin in the room? No? You are Shalin? Aha. Hopefully your slides are already there. So Shalin heads security operations at ExpressVPN, and she's been looking at how people who do not have immense budgets can nonetheless take reasonable approaches to implementing cybersecurity or infosecurity. If the AV system is willing. Bill? Oh, okay. Done, yeah. You're up. Okay, so if you have 15 minutes including Q&A. 15 minutes including Q&A.
Okay. Gotcha. Thank you. All right. Good afternoon and welcome to my talk. I'm Chelin, and today I want to be talking about how to build security capabilities without breaking the bank. So just a quick introduction of myself. My name is Chelin. I'm from the security operations team in ExpressVPN. And overall, through my career, I've been doing a good amount of SOC work. And I learned some lessons along the way, and today I just wanted to share that with you. And I'm from ExpressVPN, and as a privacy and security-focused company, we do care about security very much and take it very seriously. So, just jumping right into the thing that I want to address. There's this myth that security is expensive. And this particular belief is prevalent, especially among small and medium-sized enterprises or even startups, and is often cited as a reason why they can't do security. And, well, the whole ecosystem in the beginning is set up to direct you to buy big, shiny products. It is expensive if you let it be. A lot of you probably is familiar with the Gartner Magic Quadrant or the Forrester Waves or similar companies. They basically analyze the market and identify where different products stand within this market and who the leaders are. And you're often very much led to buy the leaders because of the trust put in the brand. The problem with this is being a leader doesn't actually necessarily mean that it's a better product. Sometimes it just means, well, actually, most of the time, it just means that you have a great marketing team, very strong sales force, and the idea is what you're paying for isn't necessarily a good product or good code or good ideas.
what you're paying for, a lot of it just goes into marketing. So as you can see, there's a lot of these graphs. Basically, you're looking at the top right corner for what has been identified as industry leaders, and often companies just go and buy the industry leaders because that's the one with the trust. They don't know what product is good, and so they rely on some ranking like this to tell them what to buy. But I would say it's a bit like your branded watches and your branded bags. It's nice, but let's not pretend that most of the money is not in the functionality. It's in marketing, it's in sales, it's in hiring famous designers to make your product look pretty. So no wonder people think that they cannot afford security when the security that's been paraded around is basically the equivalent of like Rolex watches or LV bags. But really, there's no need for it to be shiny and expensive. And today, what I want to talk about is how we can make the most of our limited resources to build practical security without all the bells and whistles. And the approach I'm taking is that of focusing on open source products. And I'm going to go through the process on how I do that. And these are the core principles. First of all, because you're buying less and you're building more, you need to invest in people with the skills and the knowledge to implement those tools. I also really want to emphasize that with a limited budget, you cannot protect everything. Even with a huge budget, you cannot protect everything, but it's especially true when you have limited resources to work with. So we need to keep things simple. Every piece of software that you add to your security suite is just additional overhead. So you have to be very careful about what you choose. But you are not alone. You can build on community intelligence. It's the collective knowledge of the open source community. And chances are, if you've thought about a problem, someone else has thought about it too. And they've probably also thought about a solution. I do want to clarify that this talk, I'm not talking about what security tools are the best. I'm also not going to talk about like a definitive list of essential security solutions to implement as a startup. Reason being that it's not possible. It all depends on your specific situation, your business, your product. What I will talk about is to go through the process of assessing your business and your products and finding tools and capabilities out there that can secure you based on your needs. And this is all pretty high level, so I'm just going to illustrate how I walk through this problem with an example. So the example here is, you are the founder of, you guessed it, another AI vibe-coded app that's so popular nowadays. It's springing up every day. A lot of them don't bother with security. And it's especially bad because a lot of their products, it's mostly vibe-coded. And people usually tend to avoid security concerns when they're vibe coding. And so this results in a lot of vulnerable apps being released and pushed out into the market that everybody is just using without thought. We don't want to do that. So in this SaaS AI vibe-coded company, your $1 million idea is an AI personal assistant that's completely unaffiliated with another popular AI personal assistant tool out there. It's integrated with, so the user would download this, and this app integrates with an LLM, and it integrates with a number of apps and functionalities so that the AI can help them perform actions. So for example, you can tell it to help me buy 5 packets of noodles from Amazon, and then the AI will just do it for you, and so on. So how do we protect our company and our product? First, you need to understand your own systems. So I'm going to break down what our product is and the components that make up this product. So it contains an app that users download, and it connects to the app connects to an LLM that you self-host on AWS to save on costs. Then you have the AI tools, which grant the AI actions that it can perform on your behalf. And of course, these tools are vibe-coded, and security is probably non-existent. You have about 20 employees fully remote because you don't want to buy an office. And you are not yet profitable, which means that money it can be a bit tight. So how do you protect a company like this? I mentioned earlier, one of the core principles is to prioritize. And here, this is what threat modeling helps you do. Essentially, with threat modeling, you're simulating threats that could harm you, and trying to figure out how they could happen. It is a big topic on its own. I could do a whole other talk about this. In the interest of time, I'm going to simplify it and say that since we are such a small company with such limited time and money, let's just focus on the worst case scenarios. And so here are some of the problems that you might run into as a small company that could kill you. So you map out your threats here, and then when we map out our threats, we start to see some common themes here around your app being vulnerable and also, as usual, your employees being vulnerable. And so we're going to focus on this for our next part. So here we're going to try to find ways to defend ourselves, knowing what our vulnerabilities are and knowing what our top threats are. So let's look at the first threat that we identified. So you have a vulnerable app, and the threat actor exploits it in some way to harm the customer, and that's really bad. When you're a startup and trying to get more customers, customers will tend to flock to your competitors if they know that your product is not secure, it's not professional. Why would they pay to get something that could harm them? And the one way that your app can be vulnerable or even compromised is if you write code in an insecure way. And we know how common that is nowadays, with more and more people vibe coding without really thinking about security in mind, or people not even reviewing the code that they vibe code. And one way to mitigate that risk is with code scanning, and the tool that I'm going to bring up here is SAMGREP. It's a static application security testing tool. You basically can define rules which has certain patterns of code that you want the scanner to look out for. And these patterns usually indicate some kind of non-ideal programming practices being used. So for example, you can have a pattern that checks for API keys being included in your code. You can have a pattern that looks for insecure functions use or lack of input sanitization, and so on. One's like asterisk here, it's not fully open source, only the community version is, but it's pretty powerful, and they do have a large library of community written tools. So the rules are the core part of SAMGREP. There's a few ways you can get rules. One is to write your own. It's pretty simple. They have a pretty good tutorial. But of course, the core principle here, again, is to lean on community intelligence. And so we use community rules that's written by various authors. They have a centralized repository to store all of these rules. The registry also has some rule sets, which are basically bundles of rules that you can activate together. All right, another way your app can become vulnerable is through a trendy new vulnerability, prompt injection. This is basically where malicious input overrides the original instructions in a prompt. And if you're an AI assistant that's executing actions on a user's behalf, that's something you really don't want to happen to your users. And as you can see, this is super popular now. Many articles, many researchers are finding these problems and writing about them on popular tools also. For this, I would suggest Nemo Guardrails. It's a tool created by NVIDIA for this particular problem. There's 5 different types of guardrails that you can set. It works at 5 different stages of interaction with an LLM. And this is the overall flow of data between your app, the guardrails, and the LLM. So it kind of sits between your app and the LLM to sort of sanity check the exchange between the two components. So for example, with the input rail, if the user submits a prompt to your app, instead of sending it to the LLM immediately, it passes the prompt through the input rails to check if it's okay, and then it sends it to the LLM. Similarly, if the LLM wants to execute something, instead of doing it directly, you check it through the guardrails to make sure it's nothing crazy, and then it reaches your app, and then you can take the action. And here's an example on how to set up a basic guardrail. I'm just gonna skim through this because I'm running out of time. So you define the guardrails. So here I defined input and output. Here you define the actions or how the guardrail should work. So here you're just telling the input rail that I want to check if the user's input contains any destructive actions. And if so, refuse to respond. And then you define what it does when it refuses to respond. And here's an example of how it would work. This is one without the guardrail, and I told it to do something shady, and it's just responding as per normal. With the input guardrails, you can see that when I ask it to do something that's against what the guardrails define, it will refuse to answer. But if I were to prompt it with something normal, then it answers as usual. And okay, so another way big threat actors can harm your company is through compromising your employees. This is a tale as old as time. There are plenty of companies out there selling solutions to deal with this problem. One way is that they get phished. Again, old story, many solutions out there. I'm not going to promote any of these solutions. I would actually say that one very, very simple and very cheap thing that you can do that foils most common phishing methods is just to enforce MFA. It costs you nothing. That said, not all MFA are created equal. There are some that are a bit more susceptible to certain types of phishing. So ideally, you use a FIDO2 compliant method. It does cost a bit more money because then you need to buy, let's say, a hardware key, or you need passkeys, which need more like policies around it. But regardless, some MFA is better than no MFA, even if it's not ideal. And then the other entry point would be, of course, the employees' devices. There's so many ways that devices can get compromised, so many things that users can do to harm their devices. And for this one, this is a pretty classic tool. I would suggest this one to protect endpoint security. It is a host-based intrusion detection system made up of 4 components. This is the sort of rough architecture I would propose for a small company. Just a single server to collect and centralize the logs, and then agents that you install on each employee's device to send the information to the server. It's a very minimalist setup. And this is what the agents are capable of. They're quite versatile. They're like worker bees that run around in their little devices to collect information and also to interact with the devices in case something bad happens. Like, for example, they get there's malware on it and it managed to run. They rely also on rules to detect malicious behavior. The rules are, again, straightforward, written in XML. There isn't like a centralized rule repository, but there are various authors out there that write rules. And also, you can convert Sigma rules to Wazo using this script.
We're at time.
Is it end?
We're at time.
It is the end of time. All right. Thank you very much.
Thank you. This is a huge topic, and I really appreciate just a few concrete examples. Much appreciated. So next up, we have Shivani is going to talk to us about some hands-on stuff with Suricata, a network intrusion, at least detection system that I used many years ago in a previous career stage. If the slide gods are willing.
Hello. Yeah, can you please keep these videos open in 0.5x? Did I move it? Oh, okay, sorry. Hi. Accepting Murphy's Law and starting. So, I'm Shivani. I'm going to talk about a demonstration of hands-on network security with Suricata. This was originally supposed to be a workshop, but with 15 minutes or maybe with half an hour, maybe it cannot be a workshop. So it's an overview of what Suricata is. And I will leave you with some exercises if you want to try out on your own when we are done with this talk. So I am a software developer at OISF, the organization that backs and funds Suricata. It's based out of the United States. It's a nonprofit. I work mostly on Suricata using C. Sometimes I also do Rust. Most of our code base is in C, and we are moving slowly to Rust. All the sensitive parts, like parsing of untrusted input. I also work on some helper tools of Suricata using Python, and some internal tooling that is used for doing the releases. You can find out more about me on my website here. Meerkat is Suricata's official mascot. That's what Suricata means. Now, Suricata is firstly an intrusion detection system. How many people actually are familiar with the concept of intrusion detection system? Very nice. So for those who are unfamiliar, which is still a big crowd, this was made by a professional artist. So this is one of those explain to me like I'm 5 videos, which I feel like are very important. Imagine you're at the airport. Now, the first thing, important thing that you go through at the airport are the security checks. Now, what does the security people do over there? They actually see what's inside your bag, but without interacting with it. They see a copy of what's inside your bag, and they have a set of rules, the items that you cannot carry, and they match it against that, and they see if something stands out, something is in your bag that should not be there, then they alert the respective authorities. So this is the IDS case. You're actually just passively observing what's inside a certain package, but you're not interacting with it. And you are alerting based on what was in there and matching with certain sets of rules. Could someone help me, please? I don't know how to work Mac.
I also don't. What do you need to do?
Am I? No. Linux for the win.
We had an unexpected laptop shortage. Sorry about this.
Yeah. So that was the IDS case. So this is what Suricata would also do. It will passively just observe the traffic that's coming to your network, network traffic that's there, and it will generate a set of alerts based on the rules that it has been provided with. Now, is Suricata just an IDS? No, it's not. It's more. It can also be used as an intrusion prevention system. It may be clear by the terminology, but the professional artist has something here as well. So this time, instead of just alerting the authorities about what's not supposed to be there, the authorities actually take an action on the item that was not supposed to be there. They confiscate the item that was not there, and they throw it out to trash. This is the intrusion prevention mode. This time you are not just, this time there was not just an interaction with there was not just a passive monitoring of the thing. You also interacted with it and you decided what should not be there and throw it out. Excuse me. Linux for the win again. See, it's hard. I'll skip playing more professional artist videos, I think.
I'm not sure whose laptop this one is, but we realized this morning that we were one laptop short. So
Oh, okay.
somebody has
Yeah, maybe
found
I
a
should have
Mac
used
somewhere.
Mine. Yeah, no, it's fine. Thank you. So maybe when you get my slides, you can get to the most interesting video that the artist had made. But Suricata is also not just an IDS and IPS, it's also a network security monitoring tool, which means that going back to the airport example, the authorities may be storing a lot of logs about the travelers, you know, what their name is, what their ID is, are they frequent travelers, how many times have they been flagged, etc., etc. So Suricata also does a lot of extensive logging for all the network traffic that it sees or that passes through it. Now, we saw what airport security rules look like. This is what a Suricata rule would look like. The thing that you see in the box over there, starting with the alert, that's an entire rule. This is a nice rule viewer that a team member, Jasonish, wrote as a part of his project EveBox. You can check it out. So this is also essentially doing the same thing that we saw with the airport example, but we want all of the things that are mentioned inside the rule for the rule to be matched, and then based on what the action we have defined for the rule, which in this case is alert, we issue that action. So in this case, if everything here mentioned in the rule were to match, then we would issue an alert. Now the output of Suricata is very, very extensive. It's also very, very configurable if you wanted it to be. But the major features that stand out to people are alerts. First of all, this is how an alert would really look like. I know it does not look like anything like the easy explain to me like I'm 5 thingy, but it's full of information that you would need to analyze anything on a packet or a flow. So this is what an alert would look like. It tells you like which was the rule exactly that alerted with that signature ID and signature, which protocol did it alert on. It was DCERPC, some things about what was the direction of the traffic when this was alerted, etc. There are also protocol logs, very extensive protocol logs for a lot of protocols out there. This is a DNS protocols log that you are seeing. So everything corresponding to DNS packet that has been logged over here. You know, where was it coming from, where was it going, what ports were it traveling by, what were the DNS specific entities that were found in this packet, in its header, in its body, etc. Then you can also get files. So files are important in malware analysis especially because you don't know what's going on in your network. So this is a file info event which is telling you that a file was seen going around in the network over HTTP. And you have information like what was the name of the file, what's its SHA-256, and it also tells that it was stored, so you would likely be able to find it for analysis later on, whether it's something to be concerned about. And you can also do conditional PCAP logging. So Suricata allows you to actually capture the entire network traffic that it sees. Additionally, you can also define whether you want to only log the PCAP which were a result of an alert. So if something alerted, then that network traffic would be logged. So anybody knows Murphy's Law? No? Yeah? So yeah, I started with that because these things keep happening all the time.
we are security people.
Yeah.
Murphy's Law is our business.
Exactly. So it states whatever can go wrong will go wrong, and it's happening. So yeah, it's also gone from my... It's Mac again?
That's true.
Yeah, I need your finger. And it's not starting.
I guess we are all switching to Linux, right? Okay, thank you. So this was a very brief overview of what Suricata is, but actually it's a very, very complex tool. Most of us have read about OSI model, and I have made a comparison with that, how Suricata, what kind of stages and what it takes for Suricata to just analyze a simple DNS TCP packet. You go about seeing the Ethernet layer, then you go to the network layer. Suricata also does the IP defragmentation, then it goes to TCP layer, and it would also do all the stream reassembly, any kind of anomaly handling, special case handling. And then it comes to application layer where DNS specific parser would try to parse the DNS packet, extract the information from the header and the body and everything, and log it or keep it in a way that can be matched against the rules. Suricata can be operated in 2 modes: live, which means that you would run it on a live network interface, or the PCAP mode, which means that you already have capture of some traffic that you can replay to Suricata and see in a more controlled environment what the result would be. So why Suricata? First of all, it's open source since 2007, unwavered. And it's licensed as GNU GPL2. I showed you the outputs earlier. They are standard JSON, which allow easy integration with Elastic and other tools that can provide you very good visual representation and queries that you can run on it. It's multi-threaded, really, really fast. Hardware acceleration is also available for Suricata. We have customers vouching 100 GB plus deployments, for which we also have talks from our annual conference, in which Suricata holds up pretty well. There are advanced protocol supports and other things that I also mentioned earlier. Now, if you wanted to run Suricata on your machine right now without knowing anything about it, you can do it. Thanks to Jason-ish again, you just need Docker, and you can pull the image that he maintains with the latest releases of Suricata, and you would just change your log directory and give your device's network interface, and Suricata can run and you can see it in action. And the logs would also come to your system. If you wanted to do it the hard way, of course, you can always go to the regular installation guide, which should ideally work just as it is, but you know, that's the hard way. Now let's come to the placement in your network. I told you one thing, that in IDS mode at the airport, we were just seeing a copy of what was inside your bag. So this is how you would need to set up Suricata in IDS mode. You would ideally have a switch with a span port mirroring enabled. So you can configure the switch that everything that goes through all the other ports where your router and devices would be connected should be mirrored to this port that has Suricata running, and it will just passively monitor everything and generate logs corresponding to those. If it was IPS, however, it would need to be before that, you know, so that it can actually make real-time decisions whether something should be allowed or not. It will still keep on generating all the alerts, metadata, everything that it would ideally in IDS mode. This is Help Me, I'm Lost guide, because we are all lost. So if you wanted to learn more, report bugs, etc., this is our Discord QR code if you wanted to join, GitHub if you want to check out. Now, this is the fun time. I don't expect anybody to do it right now with me, but these are the exercises I wanted to do in the workshop with you. So first one is, of course, run Suricata on your machine's network. There's also a do it hard way with every exercise. So if you're a beginner, try out the first thing and then the next one. Do it the hard way, run it on your home network. That's awesome. I promise it's really, really fun. Second exercise is that you write your own rule, very simple rule, to make Suricata alert for this peak app that I have linked over here on Wireshark website. And make sure that Suricata alerts at least for this specific packet. Now that would be a very simple rule. If you wanted to do it the hard way, learn what sticky buffers are and try to make the same packet match more precisely and in a more performant way. There's also a demo link if you wanted to learn how to run Suricata in PCAP mode. And the last one is that you modify this rule to make it alert. This won't work right away, this won't alert, and you have to figure out why it doesn't alert. And then there's a hard way exercise. Thank you very much for listening, and you can check out Suricata, learn more from team and community. This is the awesome team behind Suricata. I am also somewhere, I think. Oh yeah, there. So yeah, thank you very much.
Thank you, Shivani, and thank you for tolerating the involvement of Murphy. Next up, we have Peter Membre, the Chief Research Officer at ExpressVPN, who will be dealing with how we protect. I don't think I should paraphrase. I know in detail, but I don't have a 5-word answer. Do we have a microphone for you? Oh. Do you have your slides?
Yeah. Just I will run from the drop down.
Yeah, Peter, please. Where the pointer is, it says Peter. No, go up. Down one. Peter. What's happening? The web makes everything simple. Nothing is complicated. Nothing ever goes wrong. Until you have an audience. Then immediately everything breaks.
Cool. So whilst waiting for the slides, which is, to be fair, is probably entirely my fault because I was very late submitting the slides. So I'm just very grateful that they got as far as they did. Has anyone here actually done any work with like confidential compute before? Oh, one person? So it's this is one of those things that was originally kind of it's gone in iterations over a large number of years. Some of them perfect. Some of them more successful than others, and what we'll be looking at is actually one of the newer ones, the latest ones by AMD, and kind of how we can bring that into play. That's not quite what I expected. Hold on a second. Up and down. It's not in a. Okay, there we go. Right. So, this guy, his name's Gergely. And full disclosure, this is almost entirely Gergely's work. So I'm just kind of here taking credit for it. But unfortunately, he wasn't able to come out here and present it himself. So unfortunately for you guys, you're stuck with me for the second time today. So I will do my best to get all the ideas across. But it's really, really cool. But yeah, I just wanted to make sure he gets credit for the hard work that he did. So one thing I want to point out is like in this case, as is often the case of open source, particularly with these sorts of interesting problems, we didn't really invent anything new here. Mostly this was just putting the pieces together. So it's one of those cases where if you know all these things, it becomes simple. But you need to look over here somewhere to find this component, and that requires a magic spell that lives over here that no one knows exactly where it is. And you need to have this piece of hardware, but not this piece, because that piece doesn't work. Once you know where all the magic incantations are, and I imagine a lot of you have had those scripts, the ones that you kind of look in, like the Here Be Dragons, you're not quite sure why this magic incantation does what it does, but it always does it, and so every time you run it, you just pray that it doesn't stop doing it. So what we're hoping to be sharing today is stuff that we've kind of pulled this all together. So it's not really that we've invented something new, it's we found all the kind of moving parts, and we've kind of put them in one place. Okay. So a few weeks ago, we announced the Express AI platform, and this is an end-to-end encrypted system. And what's kind of unique about it versus the others is that in the vast majority of these platforms, particularly the ones that offer some of the bigger models, it's mostly privacy by policy. There are some exceptions, but that's the general rule. And the problem with that is people saying, oh, we can't read your data because we do all these bits and pieces to make sure that we can't record it, to make sure that no one else can see this. It's not really kind of our style. So we wanted to kind of take this further and kind of much further. So what we can say is we can't read your data. And that's not a promise, it's just a mathematical reality. And that's because we're running the application itself sits in a secure enclave, but we've extended that to the GPU itself, which honestly is really cool because even the data that you send across the PCI Express bus, it's encrypted. So even if you were to kind of get like pins on a board and start trying to like probe things, it wouldn't actually do you any good because the data is encrypted all the way into the card itself. And we've done this before. This isn't our first time playing with secure enclaves. Back when we released our dedicated IP service, and this service is also kind of nice because this is if you need a static IP for a whitelist or something like that. What we want to do was to be able to give you an IP address but not know what it was. And we wanted to make sure that we never could know what it was. And so this required a bit of messing about, but effectively the entire dedicated IP infrastructure runs inside a secure enclave. And this is run on AWS, and we use their Nitro Enclave platform. In fact, there's actually an interesting white paper we did with AWS on how we use the technology, because most people don't really use it for anything, well, weird, like we were doing. And it's a zero-knowledge system and with blinded tokens. So we basically made it so, again, it's not a case of, well, we promise we won't tell anybody. We literally don't know, which is, it's quite challenging to, provide a service to someone when you don't know who that person is, or what the service is you're actually providing. The problem, though, with AWS's approach is you need to trust the provider. So originally we had a very interesting architecture, and honestly, AWS implemented this brilliantly. So if you go back 10, 15 years now, you had the TPMs, the Trusted Platform Modules. And what they would do is they would basically have internal counters, so every time you ran an application or you did something, these counters would basically ratchet up. And so in effect, you can make sure that up until this point, like the same thing had happened. You loaded the same software, you'd done the same tasks, because that would affect this counter. And what you could do is you could take a password and then seal it against those registers. Now this is really cool because it means if your machine isn't in the right state, you can't get the key back, ever. Which has its other challenges. If for example, you accidentally update the kernel or something changes, and you don't know how to make it go back the way it was, that key is gone. So there's a bit of a slight foot gun scenario with this thing. But AWS was able to replicate this with KMS, where the enclave could actually attest that it was what it said it was, and it could attest that to KMS. KMS would attest back to the enclave that it indeed really was KMS, and that it really did have the hardware security modules. And then it would issue you a key, and then it would lock it to the enclave's parameters. And this is great, because what you can then do is you start up this enclave, it gets a private key from KMS that only it can ever get, and now you can use that key to encrypt things and stick them in, say, S3. And this is completely safe, because when you start that enclave up again, it'll attest itself, it'll get its parameters, it'll go to KMS, ask for the key, it'll get the key, and it can just access the files. The beauty of this is the only way to get it is from within an enclave with that signature. But if you add some software to say, copy that key out, you will change the parameters that it's tied to. And if you do that, and if you change those parameters, well, now you can't get the key. So this is really nice because it means the enclave will do exactly what it's meant to do. And I can't be coerced to get that key, because any attempt to get that key would change the software, which would prevent me getting the key. And this looked really simple, it looked really nice, it was really elegant. And then we realized there was a bit of a problem. And we discovered that on KMS, there was a handy feature, shall we say, that would allow you to remove the policy from that key. And what that means is you can get the key outside the enclave, which completely ruins the whole security model from my point of view. From my point of view, with a TPM, you get the key, and if you screw it up, you lose the key. That's the point. But a lot of businesses aren't going to want to do this. And to be fair, if they're storing things like, if it's a bank storing, say, financial records, or it's a research city storing medical records, what you're really protecting against is accidental leaks and stuff. And so, yeah, okay, maybe that makes more sense. You would rather have a bit of a fiddly kind of recovery process than lose like potentially hundreds of millions of dollars worth of data. So I do get that, but this broke it for us because that meant that someone could get the key, which meant someone could extract all the content, and that would kind of ruin the whole promise. So we had to re-architect it to work around that. But the enclaves themselves, the actual architecture, honestly, it's beautifully done. Okay. Let's go. There we go. So we went that distance for an IP address. So imagine what we would do for AI. Given what you stick into AI, like the big challenge of AI is, and you can always tell people get me when I say this because they get that smirk, that slight smile on their face, which is, are there any questions that you would ask but you don't want to put them in AI? And it's like, yes, I would love to answer this question, but there is absolutely no way in hell I'm putting that in ChatGPT or Claude or anything else because no, it's not happening. So we wanted to protect that, and if we were going to do this enclave stuff for just protecting your IP address, we wanted to go bigger and better for this. And this comes down to what if you can't afford to trust the machine your code runs on? This is a bit of a weird question to ask, because normally this bit is kind of a prerequisite. But one way of getting around that, is, as you'll see, is the solution that we use here, is what if you can kind of like seal things away where you can't touch them, such that even if someone were to get onto, say, the machine that's running it, they wouldn't be able to interfere with the process that's running. Intel SGX started it. To be fair, they almost finished it too with the slight security problems that they had. And it was a real pain in the ass to work with, so not many people bothered. But it would allow you to start a process that was basically encrypted, and also encrypt the memory that was allocated to the process. So unless you were kind of accessing it correctly, it wasn't possible to actually get anything out of the memory. Effectively, only that process could see it. This was implemented in hardware. So with that stuff in place, you can't alter the software. You can't read memory, and you can't steal the keys. So this is actually already quite nice, but it's a bit of a weird setup because your machine's running just like any other Linux machine, except you've got this weird process that it's like the others, but it's not. And so the industry kind of moved from processes to VMs because this actually makes things much simpler. What if instead of running a process, I just run a VM, and it works like a VM? I can SSH into it, I can run processes, everything's the same. It's just, it's literally walled off from the rest of the computer, both in terms of software that's running, but also in terms of the memory. So effectively, you just have this kind of like, opaque blob that runs. And if you can do that, your life gets a lot simpler. So this is your classic like hypervisor stack, and how generally the system sits, and where this actually kicks in across the whole. Well, that's not going to be a very good way of doing it, but it basically runs across the whole of the upper part and then seals it all the way up. I got no one that might make it easier. No, we're not. Okay. Well, the thing is, that was already pretty cool. A lot of companies offered that, and basically, Amazon's enclaves are a form of this. But then with the more recent NVIDIA cards, I think it started with the H100s, they got confidential compute as well. Well, now things get really interesting because you can make the software that runs on the CPU secure, and you can secure the memory, but now you can secure and basically carve off, almost like like a hardware firewall, if you like, cores inside your GPU, and then access them from that enclave, and do so in such a way that nothing can kind of be intercepted, nothing can be seen. So with this, so you encrypt the VM. So effectively, everything is encrypted. When it boots, it's encrypted. The disk it creates is encrypted. The memory is encrypted, and it's completely isolated from the hypervisor itself. So once the thing is up and running, you can see it, but you can't really interact with it. And it's usually done by the easy way of doing it is to take like a network card or a virtual device and just kind of attach it to the hypervisor. So then you can kind of talk to it as if it was just a normal server, but you can't see anything else around it. So this is quite neat. You own the hardware, you have real GPUs, and you have full control. And because you're using NVIDIA's like confidential compute, and you're using AMD's SEV SMP or SEV Snap, depending on who you ask, you now basically control all the hardware stack, and you can control this from literally the hardware all the way through up to the point where you get the GPU to attest. So this is an example of how you might set that up. I don't know how that's going to come out. Oh, it's not too bad, actually. So this is an example set that we were doing when we were trialing this out, where we would have a single server. We've got 8 GPUs in that physical server. And then basically we grab each GPU and we basically bind it to an enclave. And then we attach that to a public IP. So in effect, what we end up with, in this case, is I think 8 different virtual machines that are completely independent, isolated from each other, but also isolated from the hypervisor. And once you actually add all those GPUs into an enclave, from the host's point of view, that GPU basically just disappears. It's completely unavailable. You can't see the memory, you can't see the core. It's as if it was never there. And so the beauty of this is you can be sure that you've booted your software, and by that I mean the thing that you thought you were booting is actually what you booted. We have this already in a lot of like mobile devices and apps and stuff like that, where it all happens behind the scenes. If you do any development, say, on macOS and you're trying to ship things around, you always get those signature warnings. That's because it was very trivial to basically crack software previously because it wasn't signed. Now that stuff is signed, this becomes not impossible, but extremely difficult to pull off. So the beauty of this is that it does it all the way through, so the whole thing is attested. So in effect, you build your OS template. There's a few different ways that you can do it. That effectively has as a known hash. Let's just go down here. Try and navigate this one. The init RD is the bit that actually boots and kicks off the OS, and it has the hash for the image like hard-coded into it. This is important because each bit has to kind of layer up and verify the bit above it, and then slowly work its way up the stack. And as you move up, as you load that thing in, the measurements effectively for your current state change, and that's then checked. So when it updates these, they used to be called PCR registers. I don't know if they're still called that. But effectively, the way it works is it takes the current value and then concatenates it with the new value and then replaces it. So as you move up the stack, you can't go backwards or change out of a step. We're 6 minutes. The key thing is this chain of trust goes all the way down. So in effect, you verify the CPU against the AMD's keys to validate that it's a secure processor and it is the processor you think it is. You verify the kernel, you verify the init RD, you then validate the OS that you're booting, and then that also lets you, I think that might be the next slide. Yes, so this is when it's you're checking the state of the enclave. So you run SVS and you check to see what's the status of it. So the key thing here, actually you can't really see, I can't see that very well. But basically you can see that the setup of it and the current state. And it shows you the current microcode versions and how everything is kind of set up. The important bit is this bit here, which is, I think is a bit hard to see, but basically everything passes. There's a lot of cool things you can set on this. A lot of them you actually don't want, and a lot of them have very special meanings. So the template that we will make available itself works around that. So I'll speed this up a little bit. And this is the fun bit. So when you run the NVIDIA SMI command, you can basically check to see whether the GPU is in secure mode, and happily for us it is. So this is how you can do the AMD attestation. It's kind of weird because normally you trust your laptop and it's the thing that's on the other side that you don't trust. But this, it goes the other way. Here, you can trust, well, your root of trust is basically AMD root, and then you basically get the laptop to verify itself the other way. So, if I can back up here. I think, I just want to check that I've got the right one. Maybe not. Yeah, so this is actually, sorry, let me rephrase that. So this is giving you the attestation flow. So this stuff is actually signed by AMD. When you can actually ask the enclave to attest itself, which basically says, take your current measurements, give it to the secure chip, get it signed, and it gives you like a cryptographically signed report that you can download, and then you can basically check it against AMD's root key and confirm that the thing that signed it is the thing you think it is. If you've ever done attestation with Apple, with their Apple signing service, it's very similar to that. Sorry, I'm going too slow. Then you attest the GPU, and that's what this looks like. So this basically tells you that the GPU is up. And this you can run it from inside the enclave, so it kind of works the same way, again, as if you're just in a normal VM. So once it's up and running, you don't really feel anything different about the environment, because it's literally just a normal VM at that point. So this is it's basically a single shot systemd service that basically checks the state of the GPU. It's actually really nice. So what it does, the first thing it does is verify that the GPU is legit. So it checks it against NVIDIA's keys. Once it's confirmed the hardware is legit, it then checks the firmware is legit. Also checks against NVIDIA's keys. And only if both of those checks pass does it then go back and then say, okay, the graphics card is ready to be used and safe to be used. Obviously, you only sign a certificate if the enclave passes attestation. A key but critical point. This is actually really useful, because if you know that the thing is giving you a certificate, and you know that that thing only will issue that certificate to something that's been signed by the AMD's thing, you can then almost by proxy accept that that thing is what it says it is. It's better to do it as direct attestation, but this is also effective.
Actually, I might do something a bit different. I know we've messed you around with technology a bit. We do now, or imminently, have a 20-minute coffee break. I'm actually inclined to let you finish, but I thought if people were waiting to step out and get coffee, because there will be a queue, maybe now would be a polite moment to do so, if you're willing to finish your talk, because I would love to see the rest of the talk. But
I'm sure, yeah.
Yeah, all right. So if anyone wants to stand up and go and get coffee, go and stand in the queue, please do it now. We'll let Peter take the next, 10 minutes to finish.
Sure.
All right. Thanks.
So this is the one I thought I was looking at before, so hence my confusion. I do like these kind of style of diagrams. So this is kind of the reverse process. Again, of how you do the attestation kind of in the opposite direction. So when you're talking to the enclaves, it's useful to get their side to actually to sign something and identify and confirm that it is what you think it is. Normally this is kind of done in the opposite direction, but effectively what you can do is, if you look at this thing here, this is our certificate API. It does attestation, it signs certificates. So basically, from the user's point of view, you provide like a CA cert, so it knows to trust your system. And this is basically mutual TLS, effectively. But what happens over here when the enclave powers up, it gets keying material that it can get signed by the trusted environment. And it can then send that request off to this guy over here. And it can check to make sure that that document, the attestation, is correct. There's a few things you have to do with that. You have to check that it's at least a certain version of the firmware. So this often, well, I shouldn't say often, but when there are issues in the hardware, like AMD will release a new version. And when they do that, you want to ratchet up so that you never accept requests from older hardware. You also should include a nonce to make sure you don't get potentially a replay attack. Honestly, the replay attacks are kind of overblown, because anyway, the key is bound to a physical enclave, which is bound to a physical chip. So even if you did get the key, if you get the cert, you can't really do anything with it unless you also have the enclave. Well, to get that, you have to be in the enclave, so it's not as big as a problem as you might think. But include the nonce, and you're good anyway. So the cert API will basically check that the request it's got and the key that was used to generate that is an enclave. This is really neat because the certificate API can then send you back a certificate that you can then use. In fact, we do use here for this this stuff down here, the actual communication directly between the two. And from the user's point of view, it will see a certificate coming from this certificate authority. And because you know that certificate authority will only issue keys to things that have confirmed that it's coming from legit AMD hardware and it's running in the right versions and it can actually generate the right stuff, you can trust the cert. I mean, to be fair, you don't have to do all of this to get something very useful out of it. You can just run a basic enclave and be happy. But if you want to go the extra mile, there's a whole ton of exciting things that you can do with this. Oh yeah, so we also deliberately locked ourselves out. So what's kind of interesting is when we build the image for this, we use the same image. And in our image, SSH is disabled. Now, you can enable SSH by putting a kernel parameter saying SSH on or debug on. I can't remember what we actually set that to. But the thing is, the kernel parameters form part of the measurements of the enclave. So what that means is if I take that image and I say, cool, image with this hash is a production image. If I start that image with debug on, the hash will be different, and it cannot become and cannot get production status. Because it's a really neat little system. And this is really cool because, and of course, we have this off by default, just in case someone forgets to set production on or something like that. So obviously it fails safe. But effectively, it locks you out. And because there's no way of getting into it, because the memory is encrypted and everything is encrypted, you can't turn it on after the fact. The one thing we don't have working perfectly for this yet is the... actually, I'll come back to that. I might already mention that further down. So it's actually more interesting. So we're actually open sourcing the enclave stuff. It was meant to be done by today. I didn't finish it by today, so that's on me. I don't have a cool name for it yet, so I'm just going to call it Trusted Compute because we have Trusted Server and this does computing, so call it Trusted Compute. But what it will be, not sure that was there. Yeah, so can't go back up. Can't use the keyboard. So what it will be, so the repo will contain a number of things. It will contain all the scripts that you need to actually build a VM and build it in an RD and actually set up everything that I kind of briefly demoed. So even this, I think we've got an example for the cert authority. I think that's one of the ones that's going to go in there. I'll double check. So basically you can build the whole environment out and just see it kind of working for yourself. So you'll be able to build the image, you'll be able to boot it, you'll be able to take the VM, and you can do the entire flow that we basically talked about. If you happen to have an NVIDIA H100 or above, you could turn on the confidential compute as well. So we will include the examples for that. I imagine most people don't have one of those. I would like one of those. When I think the graphics card that we're using on one of these boxes is the B200s, and they currently retail at like $50,000 US each, and this box has 8 of them. It's like worth more than a house. It's absolutely insane. It's really cool, but it's really insane. So this is the basic flow that it will set up for you. I can't remember, honestly, if we've set up the CI/CD. I think we give instructions on it. I don't think we wire it up because that makes it more fiddly if you try to clone it or use it for anything. But it will show you how to build the OS template, how to automate that, how to do the cert API. I'm pretty sure we have the cert API in there because the key thing is that when that fires up, it does the attestation against the secure environment. And that's great because it means when you basically ask the environment for the key, it's based on how things are set up and all the measurements and all those sorts of things. And so you can make your life, you don't, Maybe rephrase that. You don't have to do that. If you just create it in the secure enclave by itself, because of the other properties, it's already, honestly, it's fine. But if you want to go the whole way, you can also then, when you generate your CSR and you generate the private key, you can generate that private key in such a way that it's locked to that enclave's specific measurements as well. So even if they did get the private key out of the enclave, it would be basically useless because you wouldn't be in an environment where you could use it. The main idea is like it's a starting point for the community to take and build on it. We're keen to work with other people and kind of add other use cases and stuff like that. But really, yeah, it's meant to be a starting point. Also, yeah, check our claims. That's kind of the whole point of this. Trust and maybe not trust and then still verify. And yeah, thank you very much for listening.
That is just fantastic. I'm actually looking to build an application that will use a bunch of this stuff, so I'm watching with rapt attention. I know we're in the middle of everyone's coffee break. Are there any burning questions while I've got the man on the stage? You have covered the topic so concisely, so comprehensively that there are no questions left to ask.
Or just babbled and made no sense at all.
That is also a risk. Thanks, Peter.
No problem, thanks a lot.
Okay, so we're actually already 10 minutes into the coffee break. We'll resume here in about 12 minutes, 11 minutes time. Thanks all.
First time.
Yeah, the time on, right? You don't keep pressing the keys and stuff. One of our speakers is like, what's the mic?
Hey everyone, I'm Dheeraj. I'll start by introducing myself. So I'm a senior flight software engineer at Pixel. It's a company based out of India where I get to work on building satellites and I write software for all the onboard compute nodes that go into the satellites. And apart from that, I also started contributing to the Linux kernel recently. And you can find all my contributions there and all my personal websites and all the relevant websites over there. So we'll be going through a personal project of mine where I've been messing around with breaking routers and then going through the firmware. So brief agenda is we'll be seeing how I broke through and firmware analysis, looking for passwords that they forgot to encrypt, and then building something useful out of it. So I've been doing this for a while, and the pictures show all the times I've broke into all the network devices. And the first picture shows me replacing a flash chip. This was one of the routers that I had at home. So today I'll be exploring one such device which is based on Alpheon. So all you need to do to break in is a USB to TTL converter. You just attach it to the USB port over there, if you can see, and that's it. You can just access all the serial messages, and you can also access the console. So that is what I did, and once I connected to it, you can see the login page that pops up once the boot finishes, and that is a message that comes up. And if you see, there's a familiar SH which says enter a Linux shell, and once I type it, it asks for a password. That's where I hit a roadblock. So there's nothing much you can do here, right? And that is where the breaking in part comes in. So they forgot to lock U-boot. So when the kernel is booting up, you can just hit any key and then U-boot pops up. So if you just type in print env, you can see all the environment variables that the company built. So there's a list of 100 such variables that they've added, and some of them have sub-variables, and it's really complex. So I started by looking at the familiar bootm command. So if you see that, hello, yeah, particular line has variables. So you can start by expanding those, and that is what I did, printing out each of those sub-variables, and you can see what's happening in each of those variables. So I started with that and expanded all the relevant variables. That is mostly a trial and error basis. And eventually, you combine all of that, and if you see the last line, I've combined all of those variables and then put it into a single command. And you also add the init sh, which gives you root access. Once you add that, then you can see that I've typed in bootm command, and then the kernel starts booting. So once the boot finishes, you get root access, and you can see the symbol over there. But there's a watchdog that the company put in over there, which keeps printing out a lot of messages, and you can't really do anything with the terminal. So you have to disable that. So I went through all the file system, and once you mount the file system using the proc file system, so you can see something called a watchdog flag. And if you just echo 1 into that, the watchdog stops. And that is when you have a proper terminal access where you can type in a list of commands. And the next challenge is that you have a read-only file system. If you look at the top, your root file system is not writable. So there's nothing much you can do over there. But if you look at the other file systems, they're all mounted on the RAM. One such example is the tempfs, the var file system, which is on the RAM. These are the ones you can play around with, and that is what we'll be doing. So going into the firmware itself, now if you type in the ps command to look at all the processes that are going on the router itself, you can see they're starting an inetd server. And that starts a telnet server within with a login shell. So I tried telnetting into the router's address, and if you see, we're getting to the same login shell, and there's that familiar sh where you can log into the Linux shell. But again, that needs a password. So now once you go into the password file, you can see that there's they're starting bin CLI, which is the login shell that they start upon login. So if you go look in the bin directory, you can see the CLI, the same thing that they're using. And if I execute it, you can see the same menu that pops up, right? So we can assume that CLI is what is taking care of the login. So what I do is copy the CLI from the router to my host PC. And then if you use object dump and then do a simple grep for passwords, you can see all the passwords that are stored in the binary. There's several ways you can store a password, and this is not one such method that is recommended. You can see all the passwords, and I'm assuming that's the day and the initials of the person that has built it. Now, if I go into the login shell and type in the same password, which is, I don't know, the build day, I get access to the shell. That's what I've done here. So they put in plain passwords everywhere in the binary. And I don't know what the first password is, but I tried all the passwords here and the last one worked. Looking again into the file system, there's another tool that the router comes with, which is Flash. I don't know what that does, but I just typed in Flash, and then you can see all the things that it can do. So a lot of things, I don't know what it does, but there's what I've done here is Flash all just dumps all the parameters inside the Flash into your terminal. So you just copy over into a text file, and again, once we start searching for password, there's again lots of passwords that are listed again in the Flash. So this is the default page that the router comes with, where you go mess around with the settings. But they don't allow playing around with all of the settings here. And if you see, there's one such option which is called periodic inform, and I'm assuming the router informs the company of something, and it is enabled by default. And you can't really disable it, it's locked out. But using this Flash tool, you can actually disable it. There's a variable called inform enable, which I'm setting to 0 using the Flash set command. Again, this is a trial and error going through the list of commands. We then save the config and reload the config using the commands there. Again, whoever developed it had really nice documentation. You just type help and then it shows all of the things you could do. So I set it to 0, and if you see, we've disabled it. It's not really visible, but that is disabled. So we've logged out their periodic inform. Not sure what data they're sending, but it's logged out now. Now, using the same thing, you can also update your beacon interval. That's your advertising frequency. It's just an example showing we can change any setting we want. Even this was logged out, but you can change. Now, once we break in, you can actually build something useful with the router here. So if you've heard of Pi-hole, which is a Raspberry Pi based tool, which you can put on any of the Raspberry Pi, and it acts like a ad blocker. This image shows the same thing here. All the web requests are routed over to the Pi, which then checks it against a list and then blocks any of the useless websites. So if you see, once you put that application, you can just select one of the ad blocking lists. By default, the Steven Black one is listed here. And if you go into the file, what you'll actually see is all of the websites which are, I don't know, advertisements, spam, whatever. So those are the list of websites, and then 00 is your local host. So when you ask for the name, it just returns your local host address. So we'll be building something similar here with my black router, and that's why I'll call it a black hole. So it's something similar where you don't use an external Raspberry Pi. We'll modify this as the DNS resolver. Now, if you look at the boot messages, they are getting a string somewhere here. If you see here, I've disconnected the admin wherever they're phoning home in the beginning, right? So once I've disconnected that, they're not getting the DNS location, and that's why your string's returning a 0. And if you see the resolve.conf, which is what the DNS mask is using, there's nothing except localhost. This is supposed to be updated by whatever this particular piece of code was doing. Now what we do here is, again, we create our own resolve file, and I've added my own name servers here. This is just a Google name server and a Cloudflare one, and restart it with the updated one. And if you notice here, I'm using the var file system, which is readable and writable. Now once I do that and do a simple ping test, you see that Google's going through, and double click, which is one of their ad sites, doesn't go through. You get your local host address. So that is blocked, right? And I ran a series of tests, and I think the best example of showing ads is ptest.net. And if you see, there's lots of ads over there, and after I've done the DNS changes, you see there's no ads over here. So that's a simple test, and there's also an online tool available showing how many, what percentage of your ads are blocked. And initially, if you show, I'm using the basic list from Stephen Black. He has his own GitHub repository where you can download all the lists. So with the initial file, I got a 25% block rate. And there's also a very huge list with 175,000 entries. Once I started using that, it went up to 40%. And if you notice, my memory usage also went up because it's a huge list. Now, with the same list, you see that my IPv4 queries are being blocked, but not the IPv6. So I'm still getting, for doubleclick.net, I'm still getting my IP address. So that's the reason why I was getting only 40 to 50% block rate. Now I updated the list with one of the scripts that was available on his repo, which takes in the IPv4 addresses and also creates the same list for IPv6. Now with the updated list, you can see that even the 4As, which is the IPv6 queries, those are also blocked. I did the same test with my personal websites and see that on the bottom there, none of them are blocked. Now I ran the same test. You see that the block rate has went to about 70%, and my memory usage is also up now. So I just tested with the AdBlock Plus tool. This is not using the router's DNS. This is just a simple test to see what AdBlock Plus is doing, and I got a 30%. Now, one last thing that I've done is, if you see at the etc directory, there's an RC35 script. And inside, they have a simple script, run test, which was really empty before. And I've added a set of instructions here. So I started my own telnet at a different port, 2323. Once I'd done that, you get telnet access, so on a different port. So that's how I can SSH into my router from anywhere in the world. Now, the router's page says that they have a lot of security features, and I wrote a big email to them saying that's not the case. We have lots of vulnerabilities, and I also asked them for an SDK so that I can look through. But they haven't responded. It looks like they don't care about their vulnerabilities, so still waiting for a response from them. So that's all I wanted to convey, and you can find a list of all my experiments with all the routers on my Hackster page and on my website. You can also check out my LinkedIn profile. Hopefully the QR codes work. Yes, that's it. Thank you. Any questions?
We've got time for about one. Okay. One of you has to ask a question.
I'm just interested in, do you know what chip is used on the router? Because I know OpenWRT is adding, like there are people working on OpenWRT support for some Realtek chips. So is it MIPS, is it ARM, and which exact Realtek chip?
It's a Realtek chip, MIPS, again, 96 something. I don't exactly remember.
Is it 9603C?
I'm not sure. I'll check and get back to you a bit later. It's on the first slide. I checked the OpenWRT website, it's not supported yet.
Yeah, of course not. It's in development. But I'm just saying that you might check it out.
Yeah, I'll get back to you on the exact chip. It's something 96. Yeah.
We might even squeeze one more in. Did you?
Yeah. So I just wonder how much time do you spend doing this hacking?
Years. I first started during COVID time. This particular about 8-9 months. It's just, so if you remember the U-boot printf environment, I spent a lot of time going through all the variables there. And that spans several pages, and you have to try out a lot of different things before you hit that command that actually logs you in. And I also tried building my own kernel using the MIPS repos, whatever's available, but that didn't work. That's why I asked them for their own SDK, but they don't respond. Yeah, I'm still trying to work out how to build my own kernel. If that works out, then cool. Thank you.
Thank you very much.
Thank you. Thank you, everyone.
Next up is me. Hopefully my slides will appear. I'm Roland Turner. I'm part, as well as being this afternoon's moderator, I'm part of the FOSSASIA Summit organizing team. I work in the protection of personal data, and for fun, I play with amateur radio. I'm working on an identification layer for amateur radio operators to assert their license privileges online in a fairly trustworthy way. So my first question, how many people in the room understand what amateur radio is? Ooh, almost 10%. Okay, that's progress. This is a licensed radio service. The important detail for this session is that anyone who is active in amateur radio must have a license from their local government, and part of that includes a call sign, which is a bit like a sort of phone number or a license plate on a car. And so the challenge is how to assert that identifier, for example, X1 CSC is a fake call sign, online, which creates a range of problems. Aha, I will speak briefly about what I'm trying to do. My code isn't working yet because I've been learning unexpected things, so mostly I'll talk about what I've been learning, and then briefly next steps. This starts with a Sunday afternoon, what we call a NET, essentially a conference call amongst the Singapore Amateur Radio Transmission Society, or SARTS. It's a hybrid on-air and online call. So we have a bunch of guys with radios and repeaters, and then plugged into the back of it, we have a thing called All-Star Link, which is a bit of software running on a server in a Singapore data center. And so the issue is that with the dashboard, I can see which stations are connected and who's talking and when they last spoke, but I can't listen or speak, despite the fact that I'm sitting there with the browser looking at the hub. That is, I would love to click once to listen, and I'd love to push to talk to participate if it knows my license. Historically, All-Star Link had this, but it was a Java applet, which of course is now unsupported by browsers, and no one's done the work to convert it to HTML5. So I'd like to re-establish those capabilities, but critically, to do it without prior setup with the operator of the service. The way the old transceiver worked was that I, as a member of the club, had to talk to the club's admin, and he had to put my call sign and my plain text password into a config file and restart the server. It's all very 90s. So my desire is to have a working identity layer that takes that step away. And of course, having built it, I want it to work for all services available to amateurs online, not just All-Star Link. So one way to describe what I'm trying to do is the sign up with Google or Apple or Microsoft, but specifically for amateur license holders. You might reasonably argue, but these guys already exist, don't they? Yes, they do. But in this case, the service operator needs to know my call sign, who issued my license, what kind of license it is, whether it's current, who issued the credential, and when they issued it. Okay. You've got most of the slide. Sorry about that. Something's missing. Importantly, the operation of radio transmitters on these frequencies is a licensed activity, and in situations where someone is allowing a remote licensee to push transmit, they have to be reasonably confident that they're legally entitled to do so. So that's why these parameters are required and why they have to be reasonably trustworthy, because the operator of the remote station is making decisions with legal consequences based upon this data. The other point, of course, is that Google, Apple, and Microsoft are really good at what they do. Well, that's fine. I'm counting on that. I'm not looking to replace them. The idea is what's called a chained OpenIDC setup. So yes, the user in the browser goes and talks to, in this case, All-Star Link or some other service. It then goes to CallSign Connect as an identity provider, which in turn goes and talks to an established identity provider who can deal with biometrics and multi-factor authentication and all that other rubbish that I want nothing to do with. Once the call sign connect service is convinced that the user is a specified user, then it looks up its table, pulls out the license details, and returns that in a custom set of parameters to the application that's relying. The idea here is that I'm building the smallest, simplest possible but useful screwdriver. I am not building a total identity service. If you look at typical commercial identity services, they have hundreds of features. My intent is to have 2. One of the first questions that comes up, and this was sort of the rationale in my talk proposal when I wrote it in September, is, oh, so we're going to make one big OIDC provider for the entire 2 million amateur operators in the world. No, it's a horrible piece of centralization. It means if it's ever down, then hundreds of services across the planet are down, which is undesirable. And of course, there's a massive surveillance problem. An OpenID provider sits in the path of every login session. So I thought, okay, this problem has already been solved for phone numbers. The enum set of standards there's an RFC series that specifies enum, provides a way to take a phone number, in this case a UK number, a +44 number, and turn it into a DNS query. And the intention here is for voice over IP. So for example, you're a SIP phone, you want to call a particular other phone, you take the phone number, cut the plus off, flip it, insert the dots, and put E164 ARPA on the end of it, and look for a network authority pointer record. If you find one of these, an account URL, you can then feed it into your SIP or IAX discovery for a voice over IP call. Thought, okay, this is nice, this already exists. It's very similar to amateur call signs, it's even defined by the ITU. Let's do the same thing. Phone numbers are defined in ITU-T E164, call signs are in ITU-R regulation 19. So I said, fine, we'll do R19.ARPA, we're all there. Obviously, getting stuff into .ARPA takes years, so as an interim, I'm using callsign.online. That was the plan. On reflection, my biggest learning is don't do it this way. There's a bunch of issues. Yes, there's a very close match between the definition and allocation of phone numbers internationally and the definition and allocation of call signs internationally. They're both ITU, they're both national allocations of prefixes. The processes are almost identical. The approach is extremely mature. There's a set of RFCs that have had thousands of hours of work put into them. And the bit of the slide that's missing is that the surveillance, if you implement it in a way that's cheap, it's just DNS. There's no web server doing cryptographic operations. It's just a really cheap DNS answer. Then A, it's less than 1% of the cost of running OpenID servers for this root service. And B, there's much less surveillance risk because everything is cached. You let the DNS resolvers deal with all the work, and therefore I don't learn anything that's useful for surveillance. The difficulties are that enum for phone numbers assumes delegation to national administrations, whoever your regulator for telcos is, and in turn subdelegations to billion-dollar telcos, neither of which is true of amateur radio. It's 150 mostly tiny national bodies who are completely incapable of running a high-stakes identification layer which others will rely upon for legally regulated activities. So in reality, it'll be one service. It won't be delegated. Worse, it causes users to have to sign up twice, once with their OIDC provider and once with the root. And the root, if perhaps not me, but some subsequent custodian of the system turns evil, they can wind the DNS TTLs down to a few seconds, turn on the request to resolvers to provide subnet information, and then they have a high-resolution surveillance mechanism for every single login by amateur radio users into amateur radio services. So it's not that it can't be abused, it's that if it was built and run cheaply, the data doesn't exist. But someone who turns to the dark side and is willing to pay a bit more for the hosting costs suddenly gets a high-resolution surveillance stream, which is a bit of a problem. It turns out that there are, in fact, better options. And so I will keep the directory for other uses, but certainly for identification, it's neither necessary nor desirable. I had a quick look through. Oh, yeah, it's got the whole slide. The colors have disappeared. All right. So, well, DIDCOM is a blockchain-centric approach, quite neat, but a bit complicated to use and not widely used. MDoc is principally used for mobile driver's licenses, and it's optimized for speed. A police officer stops you at a traffic stop, you were speeding, you ran a red light, it's a random breath test. He or she needs to be able to scan your driver's license. If it's on your phone, all that tech stack has to work reliably and fast. In the middle of a law enforcement stop, you can't both be mucking around with Bluetooth settings. And so that MDoc is optimized for that application, works beautifully, not appropriate for what I'm doing. The HTML5 digital credentials API sort of looks architecturally like the right thing to use, but because it's controlled by Apple and Google, there's considerable fear that they will use their power over its applicability in precisely the same way they've done with NFC. And so I note here in Bangkok, half of the vendors of anything, food and bev, for example, don't want PayWave. They want QR codes. And the reason is, if you're paying by QR code, you've cut Apple or Google out of the loop. If you're paying by PayWave, Apple and Google are putting their hand out for a fraction of every single transaction. The fear is they're going to do exactly the same thing with the HTML5 digital credentials API. So that leaves the most widely used system, which is OpenID Connect, which I've already mentioned. The problem is it sits in the path of every transaction. So there's a privacy risk. But I discovered, next big learning, OpenID for verifiable credentials. This relies, instead of relying on an OIDC service, relies on a wallet app in your laptop or your phone. Meaning that, although you've got to work with an issuer for sign-up, at the time you're performing a login, nobody in the world, apart from you and the service you're logging into, knows that the login happened. The surveillance risk doesn't exist at all because neither party discloses to anybody else that the transaction has occurred. So it gets the privacy aspect for it, or for identification and authentication, correct, with only a very small increase in complexity, and that is you have to have a wallet app. This also provides offline, which is useful for some amateur radio communities, and it happens also to be the basis of the EU's digital identity platform. There's now a dozen projects running across the EU, meaning that the integration work, the user experience work, and the human rights protection work has been done at the highest standard available anywhere in the world, making this an incredibly strong contender. But hang on, not everyone wants a wallet. And of course the answer is a hybrid solution. Provide OpenID Connect initially, make it available to anybody, but anyone who's concerned about privacy and willing to take the tiniest additional hop to put a wallet app onto their phone or laptop, it's exactly the same data model, it's just a different mechanism for delivery. And it happens that it's a mechanism that includes no centralization at all. And as a side effect, for amateur communities who care about offline, it'll work there too. I won't talk much about the risk management other than to say that there's a very long history of badly designed identity systems, which means there's lots and lots of things to learn from to avoid making the mistakes. And there's an existing body of what are called human rights impact assessments to make sure that you've caught and treated all the risks. The other big thing is I don't want hundreds of thousands of people uploading copies of their licenses to me. The whole point of the process is to prevent the need to upload copies of licenses. And so what I've noted is there's 4 existing systems which each have hundreds of thousands of users who have already gone through this process and had a human being on the other end already identify or verify that their license is reasonable. The means of bridging each one is different, but importantly it's possible to bridge from them, to have an automated means determine that the person who's trying to use the system does in fact control an account on one of these other systems where their license has been examined by a human being and verified to have the right call sign on it. So to get this done, actually build the HTML5 transceiver, which I'm part of the way through, a minimal chained OIDC provider and relying party, and a bridge to Echolink, just the one that I happen to want to do first, and recruit some early adopters to start getting real-world feedback on how useful this is. But as early as possible, I want to get the OID for VC working with one of the, or 2 of the existing widely used wallet applications. That's where I am. Did this make sense? Do people have questions? Is anybody working on identity? No one? All right. In that case, we are going to finish surprisingly early. Next up, we have Augustine. I would use the Teams, yes.
Carefully, don't break a leg.
Thanks, August. Augustine's going to talk to us about the identity of agents.
Hello, can you hear me? Cool. Good afternoon, everyone. I'm really thrilled to be back again in Bangkok for FOSSASIA 2026. Across the years, and especially you've been to my past talks at FOSSASIA, as app developers, we have been asking a constant refrain, right? To users, services, devices, who are you? Correct? But in 2026, we got a new entity now. Autonomous agents. Because this question now we got to ask them. But why? Here's the fact. Open source projects, if you've been in Mario's talk or in the keynote, are not just used by humans. They're being increasingly getting managed by agents, right? So now we have another new security frontier to think about. So in this talk, I'm going to unpack how this so-called benign AI agents could be the ultimate insider threat for your open ecosystem. Obviously, I'm here to tell you how you can mitigate that, right? So, identity and access controls have seen a sea change. COVID gave a flip up. Okay, now everybody's remote, so we at least got that basic web hygiene sorted. And actually, we have gone beyond password. We've gone so beyond password, we've gone beyond passwordless in the last 2 years. Correct? But here's the thing. The thing that is doing the work on behalf of you isn't even human. It has no fingerprint. It has no face ID. In fact, its identity is the model itself, right? And the identity surface also has exploded. Because what this agent can do, it can make calls, it can commit your code, it can even initiate discussions on your community channels. Have you seen GitHub discussion and all? They're all automated, right? So what does that bring us to us? We got to do something more. And then, this has brought all about the old assumption of trust holds no more. Okay, now we don't only have to verify humans, we also have to verify the agents, right? So, whenever we build an app, or whenever you as human ever interacted with an app, there's always some line of attribution, right? But when an agent uses my credential, the log says, Augustine did X, but Augustine didn't do anything, right? It was a bot. So now we have a huge accountability gap. Correct on this part? Clear? Second is, if you see the thing in a yellow, we have always used the static APIs, right, keys? But this is one of the biggest villains. Okay? Because A, they're long-lived, they're easy to copy, and they're almost impossible to track. Sorry about that. Okay? If I want to give a good analogy, it's like leaving your house key in the lock itself. Okay? Now the third box is where things get even much more scarier. What is it? Recursive delegation, aka the agent spotting sub-agents. If you're now doing software coding and you know that, right? We are now creating, you create an orchestrated agent and you will create sub-agents and all that thing. The scary part is, now you have a bunch of entities that are cropped up using your credentials and you don't know how far that chain goes. So these are almost taking an analogy of house key. Now I've given my house key to Roland and he's made 12 copies of it. That's not a good place, right? He's a good friend, but that's not what I want to aim for. We, as the largest community, OSS community in Bombay, we also have a community, right? And we also built a community app. OSS guys, we always build an app, right? And now it's also the barrier to build as low. But we also invite speakers, just like out here. And we have those very little tricky privacy thing, honorariums, fees for speakers. The agent has a vetted permissions to access that. But this agent also goes and posts it in the general channel of 200 members. That's not what you want, right? That's not what you'll aim for it. So what has happened? The requesters is not usually the recipients. That's what used to happen, right? In the good old days of OAuth, it was a simpler world. One app, one user, one app, one set of permission. We are sorted. Now, we have these elevated privileges where the agent acts, gets the requested data, context, metadata, whatever, it got access to it. And then, unknowing to you, outputs it into a mixed trust participants. That means not all participants are or have the privilege or the permission to see that, right? Suppose your salary, dude, it goes on WhatsApp or line, that's not what you want to look for. Third, the retrieval happens because now our existing access, identity and retrieval access cannot compute the lowest denominator of permission that needs to be the output. That is one thing that is failing us at first. So we have to see how we are. Now the agent we are responding, right? Some standardization coming. Hopefully everybody know MCP. Everybody knows MCP? Okay, so what is MCP for guys who have not raised their hands? We have been interacting with LLMs across, but they've all been artisanal. Our industry has now come to a standard way where the LLMs can interact with your data, your resources, or your tools. But this is also a great point. This is the way we need to put the checkpoint. Because if we don't have a way to control this, that means your model will have unfettered access to actions and tools. So this, where MCP helps us bring the structure, the onus is on us as security pros to make sure the structure is secure. Now, bearer tokens had a good run, right? But like a Game of Thrones, they need to die in the world of agents that are going to come through. So what it means, if my security token gets leaked, it can be replayed anywhere, right? No question asked. Just do it. It's like a check. You got a bearer check. You got it, you can catch it. How do we propose to solve this? DPOP, demonstrating proof of possession. So now what we are doing is that the token that is generated is tied to a cryptographically bound to the agent's private key. You could say MTLS, but MTLS relies on the underlying architecture, right? That's not correct. Because now we are working on heterogeneous trust environments. So this is the way that we are going forward toward that. We are in Asia. I'm from India. We are in Thailand. We are a very hierarchical society, right? We love roles, right? I'm an admin, he's a moderator, you are members. But they're too coarse for agent or agent workflows. What we have is we're going to use something that is very an important term in agents, context, right? Attribute-based access control helps that. What it does it? Hey, I got my time, I got my scope, I got my environment, and the most fourth crucial thing, the intent. Because now, that is the most thing that differentiates your nefarious design from the authorized one. Okay, the intent is crucial for this. You are asking is, should this agent be doing this task at this right moment in this situation? What this helps is, the precision trumps hierarchy. So you have now made sure your blast radius is very less and the scope for exploitation or leakage is reduced. So as he mentioned, as an open source, we also built an app which I mentioned about it. Here what we're doing out here. A whole bunch of things where we are trying to make sure just in time, limited set of permissions, always backed by DPOP. There's a way to secure agents and make sure that is not compromised. And we're trying to put up all these things of what it can do and what exactly. The minimum set and nothing more. We follow the same LPA as well as the TS. What we're doing is, we use Keycloak, open source project. Digital communities also, folks. We connect, get the credentials, get digit tokens, fire up, and in that, ABAC is only doing. Don't worry, mate, I got you good. So, as we bring down, and we come down to the very end of this first session, I want to also wrap up, right? What you should really do. If you look at the first pillars, please don't share. Your agent should not be sharing accounts. No, that's a cardinal sin. Don't do that, please. Okay? And then, if you look at the second one, yes, the ABAC thing I mentioned, make sure it is very less. Full, complete log. You should not only be interested, hey, what are the actions taken, but what was the intent behind that? I'm always stressing this word. This is most important now going forward. We have seen that also in software development, right? The spec-driven stuff. Intent is crucial because now there's a devaluation code happening in terms of intent. And the fourth one, human oversight still matters. We should be having the trigger point, okay, should we pull the ladder or not? Without that, we cannot move forward. For me, as Roland and others are speaking, OpenAID, this is for what we're doing for agentic AI. This is on the OpenAID, a normal, have a look at it. It's a little bit verbose, but if you are into this, and you should be, CloudBot and everything notwithstanding, please understand how you give an identity to not only human beings, but to agents. Yes, that's my talk. Thank you, folks.
Questions for Augustine? Everyone has a perfect method for controlling access by agents. Nope. Okay. In that case,
thank you.
Thank you very much. Right. So next up, Suned. Ah, wonderful. Pardon me. Go ahead.
Is it on autoplay? You can see it, right? Never mind.
Great. Go to slideshow and it's decided to do
I'll move it myself.
changes every 10 seconds. Awesome.
No, don't do that.
Full screen, no, do full screen instead of slideshow.
I'll do that. Thank you.
And then use the up-down arrows.
Yep.
Okay.
All right. So good afternoon, everyone. I'm Sumed from Red Hat. I've been working in the identity management space for the past little more than 10 years. So I work on FreeIPA, and I'll be talking about ZTA and PQC. So ZTA is nothing but zero trust architecture, and PQC is post-quantum cryptography support within FreeIPA. It mostly deals with algorithms. So let's go ahead. This is what I'll be talking about. I'll give you an overview about what FreeIPA is. Before doing that, how many of you have heard about FreeIPA or know about identity management? Okay, few. Okay. So I'll be talking about why ZTA and PQC are important in today's world. Augustine just now told us about why is this so important about ABACs now. So it's not really that, but we'll touch upon that. I'll go into a little detail about how ZTA is being implemented within FreeIPA and also PQC. And I'll be talking about a couple of research projects which are currently underway. And hopefully we'll have time for questions. All right, so this is the architecture of FreeIPA. Don't go into the details. It is a little bit complicated because there are a lot of moving parts to it. So the high level view is FreeIPA is a wrapper around a lot of different pieces, software pieces. I'll briefly describe a few. So the backend or the database or the data store for it is 389DS. It is a directory server. So all your data is within a directory server, and the reason it is called 389 because it runs on 389 port. Then we have MIT Kerberos, which is used for authenticating to the key distribution center. The most important, I won't say most important, but a very important part of the free IPA product is DocTag PKI. It is a certificate. It is not just a certificate system, but it also provides key archival and recovery, and CRL distribution, OCSP, and all sorts of things. Then we have Bind, which is nothing but resolving DNS queries. And we have Cronedy for time syncing. So with all these software components in place, the client side is handled by SSSD. It mostly deals with authentication such as PAM, NSS, then sudo, and SSH. There are two parts to this. So there's the free IPA server, and say for example, I want to connect to or authenticate to the free IPA server. I'll be doing that with the free IPA client, and that's where SSSD comes in. Then we have Certmonger. Certmonger is nothing but a very simple tool to track certificates. So it lets the sysadmins know when my certificate is going to expire, how soon is it is going to expire. So that is a very brief overview. There are other tools within this also, which I haven't touched upon purposefully. Okay, so what the heck is ZTA and PQC then? So ZTA is a security framework that operates on the principle never trust, always verify. So the traditional authentication mechanisms relied on username, password, but we now know that those are not secure enough. We need to break that. We need to break that by adding hurdles to it. So there are different ways to do that. I'll touch upon those in the next slide. So what essentially ZTA does is every access request is continuously, so every request is continuously authenticated, authorized, and validated based on identity or device health or the behavior, and also the context, which is the most important. ZTA enforces the principle of least privilege and limits lateral movement by enabling segmentation. So you can do such a thing only for a short period of time within this context. That's what it means. So ZTA, so with remote work and hybrid work, everyone is working remotely. Most of us work remotely now, and we access a lot of different services. It's not just when we are in the office, we are firewalled, we have VPNs and all sorts of things. But with remote work, we access across distributed environments, and so ZTA secures those environments significantly, reducing the attack surface and minimizing damage from breaches. I'll go over those mechanisms in the next slide. So what PQC does is provides a base for actually for ZTA. So PQC is vital because it prepares systems from imminent threats from quantum computers. We all know that quantum computers are being built, and they can and will break RSA and ECC algorithms in the near future. So PQC is a PQC. What I mean by that is one of the main challenges here is enhancing free IPA and DocTag to support dual certificate chains using post-quantum crypto. What I mean by that is Currently, a lot of end users and organizations have non-PQC or which don't employ PQC algorithms, and they want to move towards PQC. So we'll have to ensure that the existing infrastructure works with the older algorithms and slowly making the transition to the PQC compliant algorithms, which is two of them are the most important ones are MLChem and MLDSA. I'll talk about it. So let's get an overview of how is ZTA being implemented within free IPA. So there are a lot of mechanisms to do that. I think there were a couple of talks talking about a few things from here. So FIDO2 or passkeys are nothing but mechanisms which provide strong, modern, phishing-resistant passwordless authentication standards. This ensures secure sign-ins using either biometrics or hardware keys. Then we have smart cards, which are nothing but physical smart cards embedded with certificates for Kerberos-based authentication. It enhances security by requiring a physical token for identity verification. These are mostly used in governments or even in corporates where we carry a access card with us. That is one example. Next up is external identity providers, which allows users to authenticate using credentials managed by a third-party service, say Google or Microsoft or any other service. This enables single sign-on and centralizes identity management. Next is two-factor or multi-factor authentication. This is basically ensuring more hurdles before a user gets authenticated. This significantly reduces unauthorized access by just adding layers of security. Now there are two, I think I missed one, but anyway, I'll talk about it. So then one of the new things that free IPA has implemented is passwordless auth in GDM, which is nothing but Genome Display Manager. A new feature which enables users to log in into GDM without a traditional password, which streamlines the login process. This can be done either via a YubiKey or a smart card, wherein you don't have to type in a password. Next, I know I missed that part in the slide, but encrypted DNS is one other thing which was recently added to free IPA. So encrypted DNS is nothing but DNS has been encrypted over TLS or transport layer security. This effectively secures your domain name resolution and prevents eavesdropping on network traffic. This adds another layer of security within it. So this was about ZTA within IPA. Let's move on to PQC. So the current state of PQC, it's work in progress. We are working on adding support within DocTag PKI. Part of it has been done already and it is available upstream. The current work is mostly around Python cryptography, adding support for MLChem and MLDSA. MLChem is mostly standardized algorithm for key exchange, like key archival and recovery. It was initially called as Crystal's Kyber, which now is MLChem. These are standardized algorithms by NIST. And we have MLDSA, which is mostly digital signature scheme derived from Crystal's dilithium. So, but there is a downside to it. Cryptography in itself is hard and a little slow because we have to authenticate every time a request happens. What this presents us a new challenge is now we have larger key size and signature sizes. So, but this is essential in order to protect the network or the communication which is going around. So PQC adoption is also at OS level. There are support has been already added within OpenSSL and NSS, and that's what we are building on because internally we use OpenSSL, and we will also support a second backend along with OpenSSL to support other authentication mechanisms. So these are two research projects that have already been kicked off. These are sponsored by European Union's Horizon Europe project. Some of you might know about it. Especially Quark, which had a kickoff meeting last month, and a few of my teammates were part of that. So a little bit about QBIP and Quark. QBIP basically works on 5 building blocks: the hardware, the crypto libraries, OS level implementation, then communication protocols, and last one is applications. And support for PQC is already delivered in Firefox. What Quark is trying to do is practical deployment of PQC into real world applications, and FreeIPA is one such example. So I know I had to cover a lot of complicated things in a short period of time. There is a host of material available on freeipa.org about our current work, our upcoming work. You can go there and browse about it. But that's all I had right now. If any of you have any questions, feel free to ask.
We do, in fact, have a couple of minutes.
So you mentioned PQC is work in progress, right?
Yes.
And we are a long way away from PQC becoming the standard. So will FreeIPA support kind of a hybrid state where both can be used? The classical algorithms versus PQC.
Yes, that is the idea. That is the reason when I said we are trying to have a transitional environment wherein it supports the RSA ECC algorithms as well, and it also supports PQC signed certificates or chains. That's what I meant by dual certificate chains. So ensuring that existing crypto is understood and granting access based on PQC enabled algorithms. So yes, that is the plan, and it is being worked on.
Brilliant.
I think we are out of time.
Thank you, Sumit. And finally, between ourselves and the break, here we are. Vutukuri Srinivas, who will talk to us about protecting tiny AI devices at the edge. As soon as we get his slides on the screen.
Check. So, hi, hello everyone, and I guess this is the last session in this room, and thank you for being here. I'm not seeing a lot of enthusiasm over here, but yeah, well, fine. So, we are spending billions of rupees building massive data centers, and we are also we are wrapping these data centers or our AI models with the firewalls, CDPRs, or physical security layers. But today's reality is AI is leaving the cloud. And to be precise, AI is much evolving, and it is coming to the right in the hardware, which is into the edge AI systems. So for this evaluation, before the attackers do catch up with the attacking strategies, we need to come up with a solution. So I'm Srinivas, I'm the CTO of Cyber Defense, and today we are going to talk about edge AI security. So let us see what's happening around us. In the two talks previous, Augustine is explaining about autonomous AI. That is, which is very true. We are moving from assistant AI to the autonomous AI. What does that mean? In the past, AI advised the human and human has to take the final decision. But today what happened is tiny models, the AI models are taking the decisions by themselves. And these models we are putting in smart factories to hold the assembly lines. We are putting these models. We are putting these tiny models in traffic system to control the city traffic grid. And also we are putting these models in medical control. So we didn't just move compute closer to data. We moved decision making into this field. So here's the terrific reality. When you deploy a model to the cloud, you'll have a massive compute power for your security layers. You have a deep level of observability and central caching as well. But when you deploy a model to the microcontroller or a hardware or a Raspberry Pi model, you'll have a severe blind spots. So you'll end up having a lot of severe blind spots, and if you want to have it also have a zero security tooling right straight into the hardware. So it is the same intelligence, but fundamentally a very different threat model. So where exactly the attack's gonna happen? So AI isn't attacked at the rest, it is attacked at the motion. So attackers try to manipulate the entire life cycle of an edge AI. So they try to manipulate your sensor data, they'll try to steal the model weights or directly from your disk, and they try to hook your C++ runtime memory, and more probably they can poison your pipelines right from the air. So let's take this into a reality, and let us imagine we have a smart factory where we are using a edge AI camera in the assembly hall. Let us to pass the product through or not based on the validity checks. So here what happens is, since the edge AI camera is making the decision by itself, let us say an attacker tries to poison the model. So when the attacker tries to poison the model, even if the product is defective, model confidently thinks that it is okay and it validates. What do we actually think is the AI model would have hallucinated? But the thing here is, it is not hallucinated, it is attacked. So in edge AI, edge attacks rarely looks like breaches. They kind of looks like a mistake, like we have assumed it is as a hallucination. So what if they want to track your IP? So attackers can send continuous, slightly varied inputs to your edge sensors, and they'll fetch the data from your model and tries to find the patterns with it. And once they find the patterns over there, they try to manipulate your. Let us say your AI model have a temperature 0. For who don't know temperature, it is a AI parameters. And this is defined to be, if you want your AI model responsive to be more discriminate you'll give a 0 temperature. If you want your AI to be more creative, you will raise the temperature value. So if you change these values, the model will perform accordingly to it. So even if the small change in the value in the edge systems, it makes a lot of difference. So for a model, doesn't need to be stolen to be understood. So next, sometimes model weights are super probably encrypted, but the thing is your runtime is not. An attacker executes environment instead of AI itself. They can hook your runtime, intercept the memory calls happening over there, and made some mathematical changes in your model. And guess what? After changing those mathematical calculation, your model gonna perform a hell a lot. So sometimes the model is secure, but the way it runs is not. And finally, this gonna be happen poisoning on the air. So let us say a small traffic classifier receives an over-the-air update contains subtle poison data bias. It's gonna create a hell lot of chaos situations where it is exactly initialized. So these edge failures are often slow, but yeah, and silent. So how are we gonna fight back with it? So we cannot put all the cloud security available directly into the small hardwares. So if you try to run the enterprise level of security in ESC32 or a low Raspberry Pi, it might crash or it might fail. So for edge security isn't about building massive walls or massive firewalls. It's about knowing what exactly happening. So if we can observe the behavior before the attack, we can understand what exactly is happening. So as we are all engineers and developers, we have to come up with a solution, or we need to build a layered structure of open source stack to protect these. So here the trust must be verified at every stage. So the first one gonna be secure boot and the integrity check. So before the inference engine runs, we need to validate the hash on the cryptographic signature if it is up to the mark, and then only the model need to be updated. So if there is even a hash is not matching, or even if there's any change, it has to halt and it doesn't need to boot up. And the second thing is the isolation. It is better to have a model to be in an isolated environment like a WASM or a microcontrol VM, so it is hard to tamper. And the fourth one gonna be the eBPF telemetry. So here we're gonna discuss more about the eBPF telemetry. This is a game changer. So if we have a eBPF in your hardware, it observes the behavior of the model right in the kernel. You don't need to have a very heavy models, heavy securities in your software. eBPF is security web hooker. Whenever it triggers, it actually goes into your kernel and gives what exactly happening to your model and what's the expected behavior and how it is performing. And so here are some of the minimal secure edge examples. Running the Raspberry Pi, executing compiled Onyx model, integrative validations, and next gonna be the eBPF watch. So enough of theory. Here's I have a demo for you. 5 minutes. Oh God. So I have a demo. Can I quickly grab my laptop? Yeah, there's exactly my laptop. I can get it. Yeah, sorry for the issue. So So here is the demo. Let me give you a real quick context around it. On the left hand side top, we have a edge node where our AI model is running, and here we have the attacker who has gained access to our AI, and here we have the kernel shield which is built on top of eBPF. So if you can see on the top left, when I have run the AI model, it has first verified the hash, whether if it is correctly matching or not. Once hash has been verified, the model is up and running. And here is an attacker lying inside our shell space and trying to poison our data and fetch our data. If you can see, I haven't enabled the shield yet, and attacker tries to do something. And I have enabled the eBPF shield where I have used the unsafe, unsafe, so that I can be super strict. If something is happening or some attack is going to happen, my model, my shield gonna kill it ASAP right in the kernel itself. So I have enabled my eBPF, and now see when the attackers try to fetch the data from it. Sorry. Yeah, if you can see, he has injected the adversarial power. We are getting a hell lot of requests, and in the same time, the eBPF shield is blocking all at a time, which is happening in the very milliseconds. This is all happening right in the kernel. And yeah, finally, I'm gonna leave you with the final takeaways. So Edge AI is no longer an experiment. It's becoming the core of our physical operations. And as engineers and technical leaders, we must treat edge models as critical IP assets. We need to monitor executions, not just only the inputs. And finally, the cloud made AI powerful, the edge makes AI real, and security determines if it's safe or not. And thank you all.
Thank you. There's a whole category of problems I have not yet had to think about. Thank you, I think. Does anyone have a question they wish to put at this point? Right. In that case, we have to give the room up because they've got to connect all three rooms together for tonight's social event, which is in about an hour and a bit. However, for those who stay to the end, we have something a bit special. Roger Dingledine, who's the founder of the Tor Anonymity Network, is doing an Ask Me Anything. We can't do it in here because we have to give the room up, but over in training room 2, starting at 1:15, which is sort of 10-ish minutes from now. So if you are interested in the Tor Anonymity Network and would like to sit down with the founder and interrogate him, please join us in training room 2 at 1:15. Otherwise, thank you all.